Hello everyone. Am I audible? Hello. Okay. So good afternoon all. Welcome to day 6 of ATAL Faculty Development Program, and it is my privilege to introduce today's guest for the session, Dr. Anidita Banerjee. Dr. Anidita Banerjee is currently serving as CDAC Pune as a project manager, where she leads pioneering projects in aerial uh, quantum communication, fiber QKB, the Quantum Test Center, and next generation quantum computing. Earlier, she worked as a scientist at CDAC and as a researcher head and vice president at Cuno Labs Private Limited, Bangalore, where she played a key role in advancing quantum technologies. Her academic journey is equally inspiring. She completed her PhD from JP Institute of Information Technology and has held prestigious visiting scholar position at the University of New Brunswick, Canada, and the Institute of Quantum Information Information Science, University of Calgary. Dr. Banerjee also has a rich research experience, having served at the Bose Institute, Kolkata, as a research associate and CSIR full officer. She has contributed extensively to the field of quantum computing, quantum communication, and advanced physical research. In her career spanning more than a decade, she has successfully combined research excellence, leadership, and innovation. She continued to mentor, inspire, and lead projects of national and global scientific significance in the quantum domain. We are truly honored to have her with us today, and we have forwarded to her valuable insights. Please join me in welcoming Dr. Anidita Banerjee. Hello, ma'am.
Good afternoon, madam.
Good
I
afternoon,
hope
ma'am.
I'm audible.
Yeah, you are audible. Welcome, ma'am, to you now for the session.
Thank you, ma'am. Thank you for the
Welcome.
kind introduction.
Good time.
Just give me some time. Yeah, is my slide visible? Is my slide visible?
Yes, madam.
Yes, it is visual.
Okay, so now I'm going to slideshow mode now. I hope my slides are moving and you can see my slides moving.
Yes, ma'am.
Yes.
Okay, great. So thank you for the kind introduction. And now we will start talking about quantum security. So as we all know, the human desire to communicate secretly is as old as the civilization itself, or as the writing itself. And in past, several societies had developed this art of secret communication. For example, here you can see around 400 BC, Spartans had pioneered military cryptography using these devices called AICTE, and they used the method of transposition for encryption. Thereafter, there are quite many, but we just want to talk about some very selective or notable technologies that time. Julius Caesar used substitution method, okay, known as Caesar cipher. And thereafter, around early to mid 20th century, there came this electromechanical cipher device, which was used during World War II for military communication. Now we know that Alan Turing's team, they had used an electromechanical device to break the cipher which was built using an electromechanical device. And this led to the first digital computer known as Colossus. So the modern cryptography is born with computer science. And today, so again, I would like to say why this slide is important is because it shows that as the technology evolves, the art of cryptography changes, the technology of cryptography changes. And today we have quantum technology. So we need to strengthen our techniques and devices with which we encrypt the critical information to be able to survive. And this is basically the reason why we are talking about quantum security as one of the applications of quantum communication. So in today's world, the encrypting and decrypting algorithm are publicly known. So what is classified and what is important for us to protect is the encryption key. And this is important because the problem we are trying to solve using quantum secure communication or quantum key distribution is all about quantum random number generator or a post quantum cryptography is trying to safeguard the key from eavesdropping. Now, the reason because the key goes with the message as input to the encryption algorithm. And as you can see here, it also goes along with the cryptogram as an input to the decryption algorithm in order to decrypt the key. Okay. So according to Claude Shannon, um, there are three particular conditions. And here I'm talking about symmetric key cryptography. Why? Because in quantum cryptography, we will be talking about generation of secure symmetric encryption keys, which are generated simultaneously at two places which are physically separated. So he mentioned that the encryption keys or the decryption keys, they both are same. So they should be truly random. They should be of the same length of the message, and they should never be reused. So in this manner, you can ensure that the secrecy is preserved. This kind of a security is known as information theoretic security. So this security does not depend upon the computational strength of the adversary in terms of time and space. So the classic problem which we are trying to address through quantum security is the key distribution. Again, in the classical world, in all the conventional cryptography, one generates the keys and then it is transported to the place or to the person where you would want it to be decrypted physically. And there is no solution, to guarantee that this will not that this will remain secret or nobody is actually monitoring it, whether actively or passively, without the users coming to know of it. So there is no such solution, and that is the reason you will see, some government officers carrying suitcases with military people along with them from one place to the other in the trains. You'll find carrying the keys using dongle or USB. So this is a practical challenge, and the way we are trying to address is so this is a problem I was talking about, that if somebody can always look into the channel. So the word I'm using is somebody will try to monitor the keys. And since the keys are being generated and sent with the cryptogram, if somebody is able to separate the two, identify the key, then it's no longer a secret, and it poses a significant national challenge. And that is the reason you will also see a lot of political interest all around the world. Okay. So then we ask the question, what are the ideal rules of this game? As I said, secrecy is as good as your keys. Here, whenever I will be saying key, please understand that I'm talking about encryption key, which is equal to a decryption key because it's symmetric cryptography. So the key should be random. It should have high entropy. It should not be reused. It should be random. It should not be tampered. Classically, we talk about computational security, means the adversary, the computational power of adversary is bounded by space and time. If you have a supercomputer, then the chances of breaking a certain code becomes higher. So, but then in the quantum world, we'll be talking about information theoretic security, which means that, even you have been given all resources, you will not be able to, decipher it. Okay, so in classically, it depends upon the strength of the mathematical problem. And so as long as an algorithm exists or it is identified to, where you can solve it in polynomial time, at the same time, you need to solve it in a given time frame, with a technologically advanced compute machine. So these are the two, criterias. Now, when you bring quantum computing in this scenario, then there are certain mathematical problems which can be solved in polynomial in few seconds time on a quantum computer. So the algorithms are identified already. Now you need to implement those algorithms on a quantum computer. And we all know India is talking about, establishing a quantum computer in Quantum Valley. There are about 4 to 5 quantum computers already in India, small working prototypes. Now it's a multidisciplinary subject. So if you are trying to build one part of it, you need to procure the other things too. So eventually you end up having a quantum computer in your lab. So it's a very interesting area. So now we move to the quantum security, from protection perspective, not from deciphering perspective. We know that we need to come up with some methods to safeguard our cryptography, because quantum computers and quantum algorithms are there which can decrypt or which can solve these mathematical problems in few seconds. So what is the technique? There are two approaches. One is software approach and the other is a hardware approach. Now, software approach is known as post-quantum cryptography, and the hardware approach is known as quantum random number generators, or the hardware approach is known as quantum key distribution devices. Now, it is good to have a quantum random number generator because these devices kinds of give you very high entropy. At the same time, these are not bounded by the seed. These are physical random number generators, and eventually, you need to have all these three technologies together, PQC, QRNG, and QKD, and they all have to be engineered in a very robust manner, hardened manner, so that we can perform a quantum cryptography. Now, let us start with building our understanding with a bit and a qubit. So when we say bit, it is binary information. It is either a 0 or it's a 1. I said 0 or it's a 1. We represent bits by voltage levels, logic 0, logic 1, right? Now, when we talk about qubit, it is a binary, quantum mechanical unit of information. Okay, and it is 0 and 1. Okay, it is usually represented by a block sphere, but now let us try to see, how do we actually, how do I feel this qubit? So just imagine an optical device. We all have played with optical devices in our schools, in if you have coming from physics lab. So there is a device called as beam splitter. Okay, so what does it do? It kind of divides a beam, a collection, or a collection of photons into two parts: transmitted and reflected path. This is a 1 cross 2 case, coupler case. With a fiber you can do that. So good enough. But what happens when a single photon enters or gets absorbed through a beam splitter? It cannot split. So, before that, we used to think that, okay, fine, if you have one ball coming inside the beam splitter, it will either roll out or it will get reflected. But a quantum mechanical description of these quantum entity, because photon is a quantum entity, says that the photon is actually present in both the paths at the same time simultaneously. So this can be represented by the equation which I have shown you here. Ket ket psi is a quantum state. Alpha and beta are complex numbers such that their squares add up to 1. These are amplitudes, or these are probabilities of the photon getting detected at a logic 0 and photon getting detected at logic 1. So if alpha and beta are 1 by square root of 2, then the probability is square, which is half. So half the times, so now if I'm repeating this experiment with 100 photons or 100 balls, then 50 times I will find it I'll find it detected in the reflected path, and 50 times I will be finding it getting uh, uh, find it in the transmitted path. So here the reflected path and transmitted path are my logic 0 and logic 1. Just like my voltage levels here, there is a window where I define logic 0 and logic 1. Okay, so these two states, ket 0, ket 1, they are orthogonal to each other, and this is actually a very beautiful and a simple way to feel what a photonic qubit is. Taking it further, we need to understand superposition, because superposition and entanglement uh, is the strength or the pillar of all the interesting applications of quantum computing, be it getting exponential speed up use in the quantum computing, or be it generation of quantum keys, means keys developed from or detected from quantum entities, which is my photons. So superposition would mean that, for example, here the photon is in superposition of both the paths, is in quantum superposition in both the paths. We are familiar with superposition, right? Classically also, we do learn about this principle, but here I'm talking about quantum superposition. So a teacher was asking a student, give an example of quantum superposition, and the boy says mermaid. Then the teacher says, but nobody has actually seen it. And the boy says, that's simple, because the moment you observe a mermaid, it gets collapsed to either a fish or a girl. That's what I said, that when I'm trying to observe a superposition state, I will see it either in reflected path, or I will be seeing it in transmitted path. And this happens after it collapses because of a measurement. Before the measurement, it is actually in this and the other path. Okay, so that is what I mean. Now let us understand quantum entanglement. So this started with 1905 when Einstein, he said, the unit of energy is photon, and he came up with this with his fascinating ideas, but he was never comfortable with the idea of quantum mechanics because of one feature, which primarily because of one feature, which is the non-local property. And interestingly, again, Einstein, Podolsky, and Rosen, which is known as the EPR, they were discussing, trying to understand this fascinating world, and they asked a question: can quantum mechanical description of physical reality be considered complete? Now, many young scientists, researchers, they read this paper and they were, trying to prove whether it is there is existence of some we call hidden variable theory. They were exploring that maybe there are certain things we do not know happens, because how can okay, so let me just start discussing about entanglement. Then I think you will share this feeling with Einstein. And here is the Schrodinger's cat, and EPR and the Schrodinger's cat. They were all arguments against, or questioning the existence of quantum mechanics, and they eventually they became the heart of quantum mechanics. So what is an entangled state? Now, suppose there are two particles. Entanglement is always between two particles, okay? Superposition is between one state, one particle having its existence in two states. And that's why, because I'm calling qubit, had I called it d dimension, then it increases. Now, when I'm calling it H, I mean horizontal, and V means vertical. So, since I'm working with photons, so I'll be using a degrees of freedom, polarization degree of freedom, to assign a binary value, just like I did with my voltage. Okay, so the horizontal can be logic 0 and vertical can be logic 1. So I can write it as get 0 0 plus get 1 1 by square root of 2. What does that mean? If I have one particle with me in this galaxy and the other particle is there in the other galaxy, then unless I measure it, both of the particle will be in HH or VV state. So there is a correlation. It's not exactly random. It is either in HH or this is a VV. Now, this is a very interesting conversation, because from there you will see how what is the basic idea of generating symmetric encryption, symmetric keys in quantum cryptography, and also how we can generate random numbers from entanglement. Now, so HH and VV, the states are in superposition of these two states. Okay, and upon measurement, if I find the particle to be H, then I instantly know in the other galaxy the particle which is in with my friend is actually H. Okay, if I find V, then the other particle is actually V. Now, if I have 100 such states, and I conduct this experiment with the other entangled state, I do not know unless I measure the state will become HH or VV. It is only upon the measurement that I will come to know, that is after the wave function collapse, that it is either in HH or VV. So this is, in principally, there is an inherent randomness associated with an entangled states, which we leverage for cryptography, generation of distant symmetric keys. For example, just I told you, how to generate symmetric keys from entangled state. Okay, so, and random numbers also, because I do not know whether I will be getting H or V upon consecutive measurement. Now, they cannot be expressed as a separable state, and you can see the significance, and it once this existence of non-locality was proven experimentally, there were many applications. Quantum teleportation was also performed, and there's a Nobel Prize for quantum mechanics by Zeilinger, Clauser, and Aspect. Okay, so there are a lot of interesting things associated with it. Particularly, I like to talk to you about an inequality. It is called Bell inequality, and it says that the classical physics, if you follow the classical physics, then the value of that inequality should be less than 2. But if it is more, or if it is between 2 and 2 root 2, then it actually violates classical, and it is actually quantum. So that is how we certify whether it is random numbers or not. Now, this is just my only slide about computing, where this is the experiment we do in lab. This is a one photon, single photon quantum computer. It's very interesting, as one of the students from Pune had come to me for an internship, and she was building this simulator. So what we did was we added a middleware and a backend, and we have our optical setup in the lab, and we kind of built a feedback mechanism where if a student gives, so these are the basic quantum gates. Now you need to drag and drop these gates in the circuit builder, and corresponding elements will be activated in this platform. Measurement will be done, and we'll get the result. So I'll quickly show you the demo. Yeah, so you can see these are the gates, just like we have not gate, NAND gate, right? A NOT converts a 0 to a 1, logic 0 to logic 1, or logic 1 to logic 0. So here we have X, which is quantum NOT gate, and Q0 is my quantum state get 0. So whenever I'm applying a NOT gate, the result in simulation, you can see 0 and 1. I hope you can see this. This is called computational basis state. So whenever I am giving an X gate here, the output will be 1. You will see 100% result here, 100% probability, but you will see the real experiments from the hardware here. In logic 0, you will get some little amount, small amount of detections happening, and in logic 1, you will see maximum detections. So we will interpret it as logic 1. This is different from the classical because you do not need to measure the signal again and again for a NOT gate, right? But here I'm doing some 100 of experiments, 100 of detections, and giving an average number here, and that will conclude that my answer is logic 1. So you can see the probabilistic nature of quantum mechanics here. So here we drag identity logic 0 should be high. You can see here logic 0 is high. So when some measurement is completed, you will see the result here. So logic 0 is 6000 and logic 1 is 300. And I'll also tell you, later, why you get these numbers. You have NOT gate. In simulation, you will see logic 1 as the highest, 100% probability. But it's in simulation. So when you do experiment, you should be getting a higher count in logic 1, which is 5700, and logic 0 is 500. Okay. Then you have a Hadamard. Hadamard creates superposition. So simulation shows 50% probability, but in real experiment, you will see the probabilistic result, which is showing 5800, 5600. Okay, so this is how we perform the quantum computation. Now, taking it further, fine. This is something. I hope I have time. Yeah. So this is showing that this is an entangled state. Then you need to ask them whether it is. Well, I just mentioned to you, in the first slide that they are not separable state. Okay, so there is the existence of quantum entanglement can be verified theoretically, and there is some maths which I have written to you. You can see this, and you will find that this cannot happen if beta is for 5 here. If beta is 0, okay, then 4 should be 0, but it's not so. Say gamma is 0, then only 3 should be 0, which is not. So you need to satisfy the entanglement here. So you cannot actually assign values to either one of them, and you will find that you cannot write the entangled state in terms of a separable state. So this is a separable state. Okay. Now let us look at the uh, entanglement experimental setup of how we generate an entangled state. Here we have the laser. Here laser goes through a crystal. So this is a non-linear process. I think if we have physics teachers with us, you can identify, this is a non-linear phenomena where a particle of light, when it goes through a birefringent crystal, based upon its the polarization direction and the optic axis, it generates spontaneously two photons which are correlated, and a particular type of a crystal, nonlinear crystal, will generate type 2 and type 2 BBO crystal, which is what we have used here. It generates entangled states. Okay. Now, so we capture them using the mirrors, and then we kind of filter them, and we collect them in these detectors using different optics here. And there's a lot of other things along with it. It's just the optics layer which I have shown you, and this part is the transmitter, and this part is the detector. The detections are happening. This is for path A and for path B. So now whenever I'm talking about entanglement based setup, please remember there is a transmitter and there are two receivers. Okay. And eventually we will see that how we do a quantum communication between two receivers. Okay, now you can also put one of the receivers along with the transmitter, and in that way you will have two units. Now this is an inequality which I was talking about, that if it is if it is less than 2, then it's a classical it's you can explain the phenomena with some hidden variable theory, but if it is violating the inequality, if it is greater than or equal to 2 root 2, and we have actually experimentally did this inequality, and we found that it is about 2.67, which is less than 2 root 2, but it is more than 2. So yes, we have violated through our experiment, and whatever experiments we are doing is applications we are doing from the generated entangled states are certified. These are some of the results. Remember, I had shown you the generation of two photons in this setup. So for type 2, it comes out as intersection points between two rings. Now, there is not one, but actually photons which come out from these intersection points. And we have to carefully identify so that we select diametrically opposite, and we select them in pairs. So that's quite a work. There is no SOP. There is there is no training which students receive prior to this kind of an experiment. So they have to really learn through a lot of hard work, and eventually they become trained in designing or the from the optical engineering part. And not only that, the electronics which are here, the timings which we have to take care of, they are in picosecond. So though you can see the path is carrying, it's of a quantum communication. The yellow lines are quantum communication. It's the quantum data transfer, which we will be talking in QKD section. But this is actually, the rest of them all are classical optics, very precision, high precision devices, high timing, precision timing measurement instruments. So a lot of state-of-art engineering, goes with it. Now, by telling you how we had generated random numbers, here I'm showing you we have examined the randomness which we have achieved through this binary data stream generated from the entangled numbers. We already had shown that they are actually certified random from the entanglement base. And then we run these test suits, which are available online. And right now, I think the ScanMe is not working, but we'll be happy to share with you some random numbers from our setup. And we see that the results are almost ideal. So now, how does this eventually when we do quantum communication, we are trying to establish or generate. The word generate is better than distribute, in the quantum key distribution. So we are generating the symmetric keys at both the ends. Now, this is very different from the public key infrastructure which we have, which is pragmatic. I mean, there are one to many, and then a lot of communications can happen freely. But I guess that was not the case when we had moved from symmetric cryptography to asymmetric cryptography. So here again, we are in that technological, situation where how do we integrate quantum with the classical? Now, if you look at the National Quantum Mission, you will see that we are covering QKD satellite QKD. So basically, we are using or we are generating the quantum random numbers between two satellites or between satellite to ground station. Okay, and but this is quite a lot of distance, right? And you need to also do secure communication using terrestrial networks. So their terrestrial QKD networks comes into play, and you need to, maybe you can use the drones, the UAVs, the hot air platform balloons as a trusted relay for quantum communication, because using satellite, as you can see, you can cover thousands of kilometers, while in terrestrial you can cover some 100 kilometers. Actually, you cannot use any optical quantum repeaters also. So there are some challenges, but a lot of work has been going in this area. And um, yeah, fine. I mean, we'll discuss more when we move talk about the QKD. And let me just tell you that we are trying to work in that aerial platform. So in our lab, we have built these prototypes, and now we would want to test them on the aerial platforms. The challenges will be different. There will be challenges in physics from the electronics, and then also to fit this thing in the with the current infrastructure. That's another level of a challenge. Now, such works are done in India. TIFR is also working on a high altitude platform. We are actually catering to a distance of about, say, 1 kilometer. We would be nice if we can take it to a higher, more than 5 kilometer. And ISRO is looking into the drones. They have done some very good demonstrations with the Physical Research Laboratory, and recently they have also done PRL has also done some demonstrations between connecting fiber communication and terrestrial communication with CDOT. And RRI has also is one of the first players to demonstrate aerial quantum communication. And yeah, but if you particularly talk about drone-based or moving vehicle-based quantum communication, most of the works are done in China and in US, so in UK. Now, see, around 1980s or something, I mean, when this all started, uh, this was primarily the first QKD was done between 30 centimeter. Okay, but today we're talking about thousands of kilometers. We are all talking about high data transmission using quantum communication. So quantum communication has some limitations, and there are a lot of challenges associated with it. But it's not that it doesn't make it impossible to happen, but it's only that a lot of things needs to be fixed. Even quantum teleportation, people are also doing using free space and fiber. So we are in a very advanced stage right now. So let us ask ourselves this question: why are we so sure about the security of QKD, or how is a QKD protocol developed? Before that, we will look into some of the preambles of quantum key distribution. Now, what does a no cloning theorem state? It says that it is not possible to find a unitary transformation uh, which will duplicate any arbitrary quantum state. Now, what does that mean? just imagine, you can say that there is no quantum Xerox machine. So you have a white paper and you have a quantum state, say a printed paper. So you give it inside the Xerox machine, and then both the prints which comes out should have the one will be the copied version, will be photocopied on the other. But that doesn't really happen in the quantum world. Now, the reason is the maths, the linear algebra. But let us see if it can be really done or not. So we take two examples here, and we try to duplicate get psi and get phi. If we take the inner product, we come up with some square of mod of bra xi and get phi, and eventually we find that you know the state could be either 0 if they are orthogonal to each other, and it can be 1 if they are almost equal to each other. Okay, so and the reason why we had taken two states is because we cannot have a Xerox machine for one state and another Xerox machine for another state. It has to be something universal. Okay, so if I'm using the Xerox machine to duplicate one state, I should be using the same machine to duplicate any other state also. So that was the basis of taking two states, and we eventually find that uh, that um, that if there is a quantum machine, if there is a quantum Xerox machine, if it exists, because there is some arguments which I can give. For example, take a CNOT gate, then you put a controlled line, you can put 1, and then in the target line you put 0, and then it will be having 1 also as the output. So here I would say that if there is a machine that can clone a particular state, then at best it can clone a state which is orthogonal to it. And that's it. It cannot clone any arbitrary quantum state. So no cloning is not possible. And why am I discussing that? You remember I said one of the criterias for a good cryptography was you should not be able to tamper or monitor the state. So the quantum physics tell you that here you have a law, with which you cannot copy a quantum state. So if I'm encoding an information on a quantum state, a quantum adversary, leave aside classical adversary, will not be able to clone it. I just mentioned to you a quantum adversary, yeah, because a quantum adversary is very different from a classical quantum adversary. We give powers of physics. So he is super tech, I mean, he knows everything, and he just needs the technology to make it happen. So whenever we are analyzing the security of a quantum key distribution system, or any quantum cryptographer, theoretical quantum cryptographer, it's a very difficult job, and they have to think, if the adversary has a quantum computer, if the adversary has a quantum repeater, if the adversary has a quantum memory, then what would be its strength, and what will be my limitations by quantum physics? How much information can he derive? So we take care of all that. Theoretical analysis is done, and that becomes a part of fetching the or reducing the information of Eve. So now another thing is the no cloning theorem. It is the so fine. It is a basis of cryptography, and here we would also like you to note that the formal introduction of quantum of no cloning theorem goes to Wouters and Zurich in 1982, and Stephen Weisner was the one who proposed quantum money. That it cannot be forged, and it introduced the idea of non-orthogonal states in quantum cryptography, which we are using. Okay. So again, non-commutativity would mean that in quantum physics, you have an operator for all observables like position, momentum, energy. So you can see here that the position momentum in x direction, and you can see here momentum operator also in x direction. So what we say that if both these operators they do not commute, then you cannot measure them with higher accuracy, and that forms another basis of perturbing a state if you are observing. So you are introducing some errors, some perturbations if you're trying to observe it. Simply what this would mean is, I have time, right? Yeah. Simply what this would mean is, if you have, I hope you're a little aware of Heisenberg's uncertainty principle. So if there is an electron and the electron gun, it randomly emits electrons before a metal with two slits, and then you have a wall which absorbs the electrons. Now, if any one of these slits is closed, then you will see a bell-shaped probability curve. If S2 is closed, you will see P1. If S1 is closed, you will see P2. But what happens when the electron enters and both the slits are open? It is actually entering like a water, wave. It is entering both the slits together, and you will see these interference patterns. So this is a quantum signature. So if you are not observing the state, then you will see a quantum signature. And if you are observing the state, as in you are very curious, you want to know from which hole the electron, has passed, just like maybe somebody would be thinking from where the beam splitter, which I had shown you in the beginning of this slide, I'm not sure, maybe something missing. How can one photon be at two places simultaneously? And you would want to take, shine some light on the photon to find out where the photon is going, or you would want to add some light dampeners, or you want to have some kind of physics you will be actually using to find where the photon has gone, and that will introduce errors. So you do not get a quantum signature, you get a classical signature. So this is how quantum cryptography works. It is very simple. If there is no disturbance, nobody is monitoring, then you will see the quantum signature. And if there is a disturbance, now you will immediately say that, there can be disturbance because of environment. After all, these entities are very fragile, and they are very prone to losing themselves to the environment. So how you take care of that? So we always talk with some threshold values. If the threshold increases, I can give you some assignments to, you will see that whenever you are trying to monitor or using some tricks, you will see the error rate goes higher. And that actually tells you why I'm saying that this is actually a secure communication. So any perturbation or any measurement can be detected. So here again, so in this slide, I want to tell you that you have Alice, you have a transmitter and a Bob. Alice and Bob, they are the famous cryptographic couple, but leave them aside. We say two nodes, a sender and a transmitter, or, so they are connected via a classical channel and a quantum channel. And they will be generating encryption keys at both the ends. A classical channel can be an optical link or an IP network. A quantum channel is usually any propagation medium for the photons to pass. We use photons because photons can move from one place to the other. you know, so it's a flying qubit. We call photons as flying qubit. And then eventually we generate the encryption keys, and they feed into this encryption and decryption algorithm, and you get the secret message. So quantum channel is nothing special. It's just the medium where the quantum state will move from one place to the other. Now we categorize the QKD into two sections. One is prepare and measure, and the other is entanglement based. In prepare and measure protocol, if I'm having a slide, no. Okay, so in prepare and measure, we prepare the quantum state. How do we prepare? We generate the quantum state using some nonlinear process or a technique where we take the light source nearer to the quantum regime. We do some encodings on the property of the quantum state, and then it travels from one place to the other. And at the other side, we do quantum measurement. The quantum measurement, if you read the postulates of quantum mechanics, it actually generates randomness. And upon measurement and subsequent processing of the data, for which I will be using the classical channel, that I will eventually get symmetric keys at both the ends. In entanglement-based network, you have a transmitter, a Charlie, a transmitter, and you have two receivers, and you establish the QKD link between two receivers. Okay. Now, if you take one receiver with yourself and you are transmitting, again, you can have a a transmitter and a receiver pair kind of a thing. And that is how RRI and PRL have demonstrated the free space based entanglement based QKD. Now, again, depending upon the nature of the optical signal, we have discrete variable, continuous variable, but I don't want to get into this, basically this area. But what I want you to understand is the two categories, very important: prepare and measure and entanglement based QKD. Okay. Now, now I will be trying to have some fun slides so that, and eventually take you to a protocol, a QKD protocol, which is called BB84. It was proposed in 1984 by Bennett and Broussard. And so here it starts. We will be using the polarization property of the quantum state. Sometimes I lose sense of time. So I'll be using the polarization degree of the state. And as I told you, we'll be using non-orthogonal states, right? So now what does that mean? Now, if you are having a red ball and a gray ball, red ball, just like those voltage levels, I designate it with the logic 0, and a gray ball with logic 1. And this is my vertical polarization. This shows my horizontal polarization. So I have color coded the polarizations as well. Okay. And these are the representations of the quantum state in computational basis. Okay. Computational basis is what we'll be using quite often. But right now, just think that I'm asking a question 1, and my question is actually a rectilinear basis. And the answer to that would be, it is either a red or a gray, because my the right answers are red and gray. Okay, so there is an optical gadget for every question. So whenever you are doing a question, you are actually asking, you're doing a measurement. So that measurement is actually a question. So here you have, it's a rectilinear basis state or not. It's a horizontal or vertical or not. Okay. And the second question is a diagonal basis. So ket plus is 45 degree, ket minus is 135 degree. I color coded them. Ket plus blue ball, green is ket minus. Every question is a measurement. So the diagonal basis state. So I'm asking the question, is my state a diagonal basis? Yes or no? Okay. So the correct answer is, the green is the blue, the green is the ket state and blue is the ket plus state. Now, how do we play this game? Now, if I'm having one, do I have this box? Yeah, I'll just take you to this slide first. So you remember the polarizations. Now, each measurement is a question. Okay, so M01 is my rectilinear basis and M plus minus is my diagonal basis. So you have this classical box and a magic quantum box. In the classical box, see, I'm trying to explain a very important phenomena of quantum mechanics, which plays a very important role in cryptography. So if I'm having a ball, a classical ball, and I keep a classical state inside the classical box, it is a local property. The classical ball will have a state which is predefined. If it is red, it is red. Okay, and suppose each side of the box is a measurement, as I have shown it in the diagram. So any side of the box I open, a classical red ball remains a red ball. But if I have a quantum box, okay, even in the quantum box, and you put a classical ball inside it based on the quantum measurement, it should change. But, since we are talking about quantum cryptography, let us have a quantum ball inside it. And I do not know the state of the ball. Okay, I do not know in the sense that it is unknown to me. I'm an attacker. I do not know what Alice has sent. Okay, because if I try to see it, I will lose the state. So I cannot see it. I will let the ball pass through this measurement equipment or quantum box. And the moment I open the right box, if it is a red ball and I do a 0-1 measurement, I will see a red ball and the output. Okay. If it was a blue ball, and now this is very important, if it was a blue ball and I did plus 0-1 measurement, the state of the ball becomes either gray or red. There is a randomness involved here. Okay, so you are doing incorrect measurement. Okay, so if it is a blue ball and I do a diagonal, a rectilinear measurement, the state becomes either gray or red. If I'm having a red ball and I'm doing a diagonal basis measurement, the state becomes diagonal states. It will be zero. It will be either at 45 or a 135-degree. Okay, so this is and you have to understand the green and red and the blue and green, they are non-orthogonal to each other. So this is conjugate coding, or this is, we discussed non-orthogonal states. You cannot copy them. Okay, so it is your no cloning theorem is coming to your rescue, and the uncertainty principle, because of that, you will be introducing some errors here in your measurement, and that gets reflected. Okay, so coming back, so these are your measurement basis, rectilinear basis and diagonal basis. And this was just a representation and to show you why they are non-orthogonal to each other. 45 and 135 are orthogonal, 0 and 90, but 90 and 135 are not. Okay, so here again, so here is a little maths about it, because this is actually not a magic. It's because of the maths that this magic happens. So earlier I had mentioned that if the operators commute, then you can measure them with certainty. If they do not commute, you cannot measure them. So the measurement operator of rectilinear basis and diagonal basis, they don't commute with each other. Okay, they are not zero. The measurement operator of M0 and M1, they commute. So you can measure them with high precision. With plus and minus, they commute. But -0, -1, they don't commute. And that is the reason we are using this principle in quantum cryptography. So then now our case becomes very simple. Okay, so you have a state which okay, and based on that information. So for example, Alice calls me and says, hey, I am sending a red ball. Okay, fine. Then I will be doing measurement in 0-1 basis, computational basis, and I will get the right color. If she sends me a diagonal state and said, hey, I sent you a blue ball, then of course I'll be using a diagonal basis measurement device and I will get the right state. So asking right question or doing the right measurement, I will get the right answer. Now, if Alice does not tell me which state she has sent, and she sends a red ball, and by mistake I used a diagonal measurement device, then I'm losing my state. Okay, the state from red becomes green or blue. Similarly, it happens to the other state. So asking wrong question or doing the wrong measurement, you will get the wrong answer, or you will get random answer. So half of the times you will be right randomly, and half of the times you will be incorrect randomly. So asking right questions or doing right measurement, you will get the right answer. You are not perturbing the key. I mean, your perturbations will not be disclosed, identified by the Bob. Okay, you will go unnoticed. But asking wrong questions or doing wrong measurements, you will get random answers for which half of the times you'll be right and half of the times you will be caught. So the attacker, the quantum attacker, actually plays with the instrument, plays with the algorithm, finds the loopholes in the experimental setup to explore the situation. Okay, so asking wrong. Okay, fine. So only Alice knows the correct question, of course, because she has generated the state. Eve will guess the question and will introduce disturbance. Okay, because at least we believe that Alice will not be calling the attacker and the eavesdropper every time and saying, this is what I'm sending. This cannot happen. This should not happen, and then Eve will be trying to measure randomly, and then that is how he will be detected. So what I explained to you right now is the Bennett-Prasad 84 quantum key distribution protocol. So in one slide, this is how it will happen. And this is how we generate the key. So the logic 0 is represented by these two horizontally polarized state and diagonally polarized states, ket minus. Logic 1 by vertical state and ket plus. Okay. Now Alice generates some random numbers and then she encodes them in the polarization. She will generate entangled or a quantum state and then she will encode them. And this happens using some optical gadgets. And then it will fly to Bob. So Bob, on reaching Bob, he unlike, he will not have information on which all qubit are in which polarization. So he will be randomly he will be measuring the states and he will be detecting 0, 1, 1, 0. And thereafter, over a call, he will just say that which maces he has used. So Alice will say only that you have done the right question or the wrong, you have done a wrong instrument. That is all. Based on that information, they will deduce the secure key. Okay. So what is important here is Alice never tells Bob about the key. She herself doesn't know the key. Okay, because it will arise out of the randomness of measurement, quantum measurement. Even in the fiber propagation, that is anyway a part of the technology that this randomly some photons will be absorbed. Okay, but it's basically the quantum measurement and the principle that the quantum state exists in the superposition of multiple possibilities, which actually safeguards the quantum cryptography. So now this is the architecture. So whatever we discussed right now is actually the quantum data transfer, where we generate the quantum state, we encode it, and then we send it to the other place. And the Bob, does some measurement, and he's able to find some, and then they eventually find the correlated keys. Okay. So I also told you how this correlation, it's not very random. Okay. But there is a correlation, there's a hidden correlation which we exploit to derive the keys. The keys are never transferred. The keys are not distributed. They are generated on the fly under the nose of an eavesdropper. And that is what we call as raw key. So after this process, all the other things forms part of post-processing of the key. Sifting, error estimation, error correction. In error estimation, there should be a threshold. There should be a threshold error value. If it is more than that, then we discard. Otherwise, we keep it. Okay. And why do we have? Okay, we'll discuss that in the next slide. There's a lot of analysis. Remember, I was talking to you about the theoretical, cryptographer, quantum cryptographer who works on the security analysis. So a lot of work goes in this area. Mathematical analysis happens here. Then there's a privacy amplification, and finally we get the secure key. So the length of the keys also gets, keeps on reducing based upon the methods, each and every method which is here. So one such, error correction is important here because we know that the qubits are fragile and they have a tendency to align themselves with the environment, and the detectors or the instruments which we are using, they are non-ideal. In fact, the efficiency is only about 65 to 70%. And in some cases, it's only 10%. There is no guarantee way of generating an entangled source or a single photon source, or even if you generate source near the quantum regime, there it has a finite probability of having multiple photons. And why am I so concerned about them? Because the information which is there in multiple photons, here I'm talking about maybe 2 photons, still a quantum eavesdropper can pluck out 1 photon and get the information. So I have to find out all such cases, and I have to see how much information can be, Eve's information can be reduced. So error correction is a very important part because it tries to find out the error which has happened, because see, both the parties are getting independent detections. So the partially correlated keys, partially why? Because of the quantum correlations. you have to refine them. So you will be using some error correction techniques. This is not the quantum error correction on a quantum computer. This is a classical error correction, and there is a Shannon's limit to it. The error correction can happen unidirectionally or bidirectionally, and there are some candidates for that. So after that, we find the error corrected key, which still has a chance of having some keys may not be same. So we do key reconciliation. We also do privacy amplification. I think there's a next slide to it. So here again, when we talk about the qubit which we are using, which I think just a recap, of what we were trying to talk about, because entire quantum communication is done using photonic qubit, and qubit is a two-dimensional quantum system, which means that it is its Hilbert space is spanned by two basis states. Okay, two orthogonal states, a horizontal, vertical, ket plus, ket minus. Ket 0, ket 1 forms the complete basis, and we call it computational basis. Okay, and all forms of qubit can be represented in the computational basis. Some encoding techniques, whenever I was talking about, that you have a random number and you are encoding that in the quantum property, it can be polarization, it can be phase, it can be time, it can be space or path based. Okay, I don't want to go into the details of it, but there are different techniques, and there are no standards. So it's an R&D, and still there can be some techniques can be proposed to encode qubit as well. So now we come to the privacy amplification, which is nothing but an attempt to reduce the information, Eve's information about the key. So here we follow a generalized privacy amplification theory, and it's a very complex subject here, and because we are trying to understand where all the information has leaked. The information has leaked because of the photon statistics. Information has leaked because of the other degree of freedom, or the footprint of other degrees of freedom. We are trying to understand how much, what are the security boundaries and perimeters for Alice and Bob. Based on that, we are trying to find out how much information has gone because of parity sharing during error correction. We are trying to find out, as according to the strength of the quantum adversary, we classify the quantum hacking with respect to the strengths of the quantum adversary, whether it has a quantum computer, whether I'm treating the qubits as a separate entity and I'm doing separate measurement. So all that is being considered and analyzed, and we decide the shrinking factor. This is how a prepare and measure kind of a QKD looks like, which is something which we are doing in our lab. We have a source and we have an encoder. This is a compute and communication engine, because there is a layer of optics, there's a layer of analog instruments, and there is a layer of those the firmware which is riding on top of it. So there is a state machine, and finally there is an application. So there are different layers of QKD, which we kind of represented using this block diagram. The classical channel, the time synchronization, Alice and Bob, even 100 kilometers apart, they have to be picosecond synchronized. The picosecond synchronization, the data processing for such precision and such data are done with state-of-art compute systems. This is a setup which we have in our lab. Transmitter be doing B92. The specialty about B92 is as you can see here, in BB84 you found 4 non-orthogonal states. Here you will find just 2. So whenever there is a ket 0, which is a horizontal state, upon receiving it on the other side, it is actually the vertical state which will be logic 0, which will carry the same binary logic. But maybe perhaps some other talk, I'll be very happy to explain this QKD. But at the moment, you just you need to take it as it is right now. So whenever I'm sending a horizontal state, my Bob will be receiving a vertical state. There is no detection, no bit. Then if it is a 0 state, ket 0 state, and I'm getting a ket minus state, this is considered a valid detection of logic 0. Similarly, if I'm sending a logic plus state, ket plus state, and I'm getting ket 1, that's a valid recognition that ket plus had been sent and a valid recognition of logic 1. So this is how we, so some test cases where I'm sending logic 0, and you will see that my logic 1, my ket 1 has the highest, has more number of detections, and this is interpreted as receiving logic 0, as what I had shown you here. See, I showed you ket 0 and ket minus state, ket 0 and ket horizontal and ket minus state. This is my logic 1 and logic 0 is my ket plus and 1 state. Ket, I'm sending here ket plus and minus. So I can always assign this as 0 and this as 1, but it has to be in both the notations has to be followed in Alice and Bob. They have to be similar, So once you're sending random numbers, so you will see detections at both the sides at almost an equal number. Now at present, so I think I have 15 to 20 minutes, right? So here I wanted to show you that this is the Indian market. There are some Indian startups and government R&D organizations, some industry partners, and the products are already there in the market, QRNG and QKD. Okay, and this is the global market. So many things are already there. We know that in 2035, there is a mandate in US and Europe to transition to post-quantum cryptography. And this is happening. Why? Because the threats are actually real. Okay, and that is the reason we would want more academia participation, because though there is still an opportunity for proposing new methods of encrypting and decrypting, there is an opportunity to develop indigenous modules, the electronics module, the detection module. Most of the time it's imported, so there is a necessity to understand how these things work. And since I have been working in this area, it is something which is not really it needs to be imported. These can be homegrown, not all of them, but at least most of them can be homegrown, and most of them can be developed in-house. So that is the motivation. And here we have actually in our lab we have built this platform, free space quantum entanglement test bed for different applications. Now this was under the project which we got from MIT, Agile and Ad Hoc Free Space Quantum Communication using drone. So we are actually trying to build a drone platform for doing quantum experiments. And why this is interesting is because using the same platform here, we are generating the entangled source, we are observing, characterizing them, and also we are doing applications like QKD and QRNG. Okay, so using this test bed, students can actually feel the quantum entanglement, and quantum entanglement is again a very special case of quantum superposition. So unless these experiments are done in-house, or you have a kind of feel of the subject, it becomes very difficult. So for that we are proposing this for Center of Excellences, and we have received a Director General Award also in that direction. And I think, yeah, this is my last slide. Our lab was inaugurated in March 2024, December 2023, and equipments, full-fledged lab started in April 2024. And we also participate in science activities, trying to, how we use laser to show the quantum states. And you can see the magic boxes. We have also developed some small kits as quantum magic boxes, where we try to explain how the state changes. And this is our team. So now I'll be very happy to take questions from your side. I hope I could, I still have time, right? I have some 10-15 minutes, right?
Yes, ma'am, we can take up some questions. Audience, participants, do you have any questions? can please raise your hands. We will unmute you. Any specific question? So at least one question from my side, ma'am. This quantum computing, actually, I'm thinking on it, so that's why I asked. This quantum computing does use any concept of cryptography? I mean to say SHA 256 or some other cryptographic mechanism, specifically in case of cyber security, I'm asking.
Yeah. So as you have seen that the quantum information is a different approach. So and the SHA or the of course, we use hashing for the quantum cryptography part. But if you're talking about how this replicate in quantum, is that what you're asking? How these mathematical algorithms replicate, or how
Yes,
do I do a quantum part of SHA?
Right.
Yeah. So so the algorithm has to be built on top of qubit. So quantum information processing is very different. So you need to build the same algorithm in a different fashion. There is no such equivalent counterpart, but those algorithms has to be designed. Of course, hashing can be done, but when we are talking about hashing, we are using the classical hashing only. Okay. And what we said that when we spoke about that the mathematical hard problems, I was indicating the prime number factorization. So it is one way function, but in quantum algorithm it can be solved.
Thank you, ma'am. Participants, any questions from your side? Any questions?
Please don't hesitate. Yeah, please don't hesitate to ask any questions.
Yes, this is a learning session. Your all questions would be handled and answered. If you have any questions, whether it is small or any range, you can please ask your questions. Yes.
So again, if you are interested to learn more about quantum computing, the slide where I was talking about the superposition is from my professor, Professor Anirban Pathak. I was actually a master's student from electronics, and I did my PhD in quantum physics. So that's a very good book. And John Preskill, Nielsen Chuang are some of the books which I think I can refer them. At the same time, I think that there is a lot of online sessions and books now available. About 18 years back, there were hardly few, and we were supposed to read the research papers and trying to understand. But when I started doing experiments, it actually cleared my concept. So please don't hesitate to ask if you really have doubts about the superposition, quantum superposition, the quantum interference, or if you would want to do some experiments, then what should be a good thing to start? I mean, I think every one of us are aware of Qiskit module. If you would want to try some small algorithms, you can start by developing a NOT gate as a quantum NOT gate, some small multipliers, quantum multipliers. Some reversible circuits can be a good way to start, as actually I had also done the same. I started off with building some reversible circuits from classical to quantum, synthesizing reversible circuits for different mathematical functions. And this is how eventually, I started moving in this direction. So that can also be, please feel free to ask any questions you would like, you have in your mind, if you would want to venture out in this space, or any applications you have in mind which you would like to explore with your student.
Yes, any questions? Please feel to ask it.
Yes, madam. Madam, it's in chat, it is mentioned. Ma'am, Neeta ma'am is asking, do you think AI wellness tools will be accessible and affordable for everyone, or only for the privileged groups? Sorry.
So I think it's the second question Jyoti madam is asking. As quantum computing, there is third value, true, false, and superposition value. I'm keen to know more about of this. Just short inspiration. So here it is actually true, false. If you say true, let true be 0, let false be 1. In quantum, it says 0 and 1, something which can be in both the states simultaneously. And that is actually the interference, the quantum interference. But when you are actually observing the state, when you are collapsing the state, the result is a possibility. Now that possibility, how much correct it is. So for that, you have to do multiple measurements. Upon doing multiple measurements, you will see that the right answer is. And that is one of the reasons, even when we're trying to build algorithms for decrypting, Shor's algorithm, the answers are probabilistic. So there will be multiple answers here, and you'll have to find the right one. And for that, lot of repetitions, increasing the fidelity of the qubit, increasing the duration of the processor. Right now, see, in our laptops we have qubit, or we have bits, and they stay for a long time, seconds, hours. But in a qubit system, the quantum computer, or the operation happens only for milliseconds. So in millisecond or a microsecond, how many operations can you do? So there are different challenges one is trying to address. And coming back again to your question, so superposition is true and false together, 0 and 1 together, unless it is measured.
Yes, ma'am. Jyoti, ma'am, as quantum computing, there is a third value, true, false, and superposition value. I'm keeping to know about how more of this just short inspirations.
Yeah, I think I have answered that question.
Okay. Next, Neeta, ma'am. Wellness data is very personal. How can AI ensure privacy and data security?
Yeah, I think this is a data AI. I don't think I should be taking that question. But yeah, coming back to AI and quantum. So quantum AI is, of course, very much people are talking about. And if you want to use AI, you can use AI to strengthen or to enhance the performance of a quantum computer, as well as to do applications for a classical computer. So AI and quantum are quite related, but I know I have not answered this question.
Okay. Anyone? Yes. Any other questions? Please, participants.
Somebody is saying to unmute.
Okay. Yes.
There's a hand, I think. Yeah.
Just a minute, ma'am. Yes, ma'am. Yes, please ask your question.
Yes, ma'am. Ma'am, it was really a wonderful session. Thank you so much. It was insightful too. Ma'am, I have two questions. You were talking about testing the adversarial attacks, right? Like if suppose the adversaries are using the quantum machine with them. So what are the attacks we will be testing, ma'am?
So we classify these attacks as, on a broader level, as incoherent, coherent, and collective attack. Incoherent would mean that something like an intercept and resend attack, where we are observing, measuring each and every qubit, which is each and every photon which is going, because we give all the powers to quantum adversary. They can also see if there is if there's a bunched photon, they can pluck out one of the photon, take the information. They will not introduce any errors. So we can say one category is man in the middle, intercept and resend attack, photon number splitting attack, beam splitter attack. This is incoherent attacks. Then collective attack is more advanced than incoherent attack, and it comprises of having a quantum memory. a quantum memory. And the third attack is a coherent attack. It's the most powerful attack. It enables the quantum adversary to use a very high dimensional probe and measure all the states simultaneously. So you have a quantum memory of high dimension. You have a quantum computer of a high dimension, and those are very much theoretical in nature. So here, to answer your question, if you would want to experience how to do a quantum attack, then intercept and resend attack is a very practical attack, where you buy the measurement, you buy the machine from the same vendor. And when you have a quantum transmitter, the attacker puts its receiver, and then once it receives, it creates states. You have the transmitter here, and then it goes back to the receiver of the Bob. Okay, so this is how the intercept and resend attack usually happens, or man-in-the-middle attack.
Yes. Any more questions?
Thank you, ma'am.
Okay. So moving to the end of the session, I'll thank to the ma'am. Vote of thanks for the session on behalf of Sadhu Vaswani Management College. I sincerely thank Dr. Anindita Banerjee for her insightful day 6 session on quantum computing and communication. Her talk offered valuable perspectives on current advancements and future opportunities in this cutting edge field. We appreciate her time, effort, and clear responses to participant queries. Once again, heartfelt thanks to Dr. Anindita Banerjee and all participants for making today's program impactful. Now we will conclude today's session 1 and proceed for the next session. I hand over to Mr. Dheeraj Chogule. Thank you, ma'am. Thank you for lovely session.
Am I audible? Good afternoon, everyone. A warm welcome to all participants for second session of the day 6. This afternoon, we find ourselves at the epicenter of innovation and exploration, where knowledge takes flight and translates into meaningful impact. It's my pleasure to introduce our esteemed speaker for sessions 2 and 3, Dr. Sharnil Pandya. Dr. Sharnil Pandya is not just an academic. He is an innovator in the fields of informatics and artificial intelligence at the School of Computer Science, Northumbria University. His inspiring journey began with a master's degree in information technology from Swinburne University in Australia, followed by a doctorate focused on the Internet of Things. For the past 15 years, he has dedicated his life to nurturing the next generation of bright minds, teaching an array of subjects including AI, data science, IoT, and embedded systems. But what truly sets Dr. Pandya apart in his visionary approach to research? He dives into interdisciplinary projects, exploring how artificial intelligence can revolutionize areas like sensors, information processing, wellness, acoustics, and even computer vision. With an impressive track record of over 90 published research papers in leading international conferences and journals, alongside 4 patents published and 1 granted. His contributions to the scientific community are nothing short of extraordinary. Dr. Pandya's brilliance hasn't gone unnoticed on the global stage. In 2021, he was awarded the prestigious Mary Slowacka-Curie postdoctoral fellowship. He's also played a pivotal role as a co-investigator in an groundbreaking research project that secured more than 222,000 euros under the European Union's Horizon 2020 program. His impressive portfolio includes research grants such as 100,000 Swedish krona for heart classification projects and another 100,000 euros from the Disability Research Center at King Sud University, focused on monitoring elderly daily activities and dementia. Beyond his impressive research journey, Dr. Pandya is a beacon in the academic community. He reviews for esteemed journals like IEEE Transactions on Industrial Electronics and Nature Scientific Reports. And he serves as an academic editor for respected publications, including the Journal of Biomedical and Health Informatics and Frontiers in Computer Science. Today, we are in a for Today we are in a for a real treat. Dr. Pandya will guide us through two captivating sessions. His first session on artificial intelligence for wellness, where we all explore how cutting-edge AI technologies are reshaping the healthcare and wellness landscape, and the second session on artificial intelligence for acoustics, where he will unveil the future of AI in sound, speech, and acoustic applications. And there is so much more alongside these enlightening sessions. Dr. Pandya will also provide valuable insights into postdoctoral opportunities abroad, as well as strategies for obtaining international research funding. An incredible chance for all of us to expand our academic horizons. So, dear participants, let's embrace this enriching journey together. Please join me in extending a warm welcome to our outstanding speaker, Dr. Sharnil Pandya. Sir, I request you to take over the session, and the platform is all yours. Thank you so much.
Thank you very much, sir, for a warm welcome. And it's great to interact with everyone. So during the session, if you can help me a little bit with the audience questions, so I want to make the session more interactive. And I hope, sir, the screen is visible, right? Hello, Dr. Chogle, screen is visible, right? And am I audible? Hello.
Yes, sir, you
Anyone
are
can
audible.
Yeah,
Yes, sir,
audible,
yes.
right? Yeah.
Yes.
Thank you so much. So hello, everyone. Today, actually, we're going to talk about AI for wellness. So I'm going to touch upon the area of healthcare informatics. So what I've planned today is we'll discuss what is healthcare informatics, some of the subdomains where a lot of research is being carried out by various researchers all around the world. And we'll discuss some of the AI case studies. So the way I've planned the session is, along with the fundamentals, we'll discuss a bit of coding in the context of various applications. So these are some of the applications I've planned, and I'll discuss some of the ongoing research projects with other foreign universities and industries. And I'll discuss some of the future research areas in the end, which we can take the research forward in different areas. And as I discussed already, that I want to make the session more interactive rather than a preaching session. So feel free to ask any questions during the session, and we'll make it more like discussion. We can learn from each other, right? So that you can take some key takeaways out of the session. So before I begin talking about AI, let's talk about what is informatics. Basically, informatics is nothing but intersection of three important entities, that is people and the disciplines such as information technology and people. These three things together actually talks about informatics, which is nothing but study of behavior structure of any system that can generate, store, and process information. And when I add this keyword called healthcare, so basically it is intersection of computer science, information science, and healthcare. Now, healthcare is really important here because like I'm basically from computer graduate, and I know that we have vast variety of audiences from different faculties. So I'll try to talk about technical stuff along with explaining it in more layman language so that we can discuss more on this. So basically, while applying technologies such as AI or IoT, how we can actually use domain knowledge of a particular application or area and combining with healthcare, that intersection will actually become healthcare informatics. And the reason I'm discussing this slide, actually I put it here because a lot of people are actually doing research in healthcare, but it will really help us if we can be more focused. So when I combine healthcare informatics with bit of automation, so let's say talk about some sensors, some AI algorithms, and some of the other technologies such as the ma'am was discussing about quantum. So this will bring some more automotive systems here, combining with healthcare informatics, and that is actually where the current research is actually lies. So these are some of the subdomains of healthcare informatics. So let me give you brief information. So those who are working in clinical department, maybe nursing staff, healthcare staff, others. So if I talk about UK, as basically I'm a professor in UK, so here we have NHS. So all the staff who are working clinical department, when we apply informatics there, that will become clinical informatics. So clinical informatics is very different research area from medical informatics, where you actually talk about how to apply technologies such as AI and IoT in the area of medical field to solve various medical issues. So example is maybe you want to detect the possibility of dementia, Parkinson's, or you want to detect heart attack, or bone cancer, or teeth cancer, or there are many possibilities are there. So again, the same thing, when we apply informatics into medical, that will become medical informatics. Same way nursing. So when we try to solve various nursing related issues by applying informatics, that will become nursing informatics. Public health informatics. So we all have actually faced COVID, right? And such diseases. So whenever uh, such, let's say COVID-19 or Spanish flu or this kind of disease, actually you try to solve and you try to find the impact of that, and you try to find the spread of that, and you want to detect those kind of things, that will become public health informatics for the awareness of public. When you combine biotechnology with informatics, that will become bioinformatics. When you apply medical imaging to detect things like bone cancer, cervical cancer, or let's say CT scan, like finding cough and bulgum to detect something like COVID, that will actually become imaging informatics. When you actually do drug discovery, when you deal with different kind of e-pills and different kind of areas, personalized medicine, so that will be the area of pharmacy informatics. When you work with, as I talk about teeth cancer, cavity cancer detection, and those kind of things will become dental informatics. And e-health, telemedicine, a little bit outdated areas. When you actually use latest technologies to connect to doctors and something like remote patient monitoring, that will become e-health and telemedicine. And when you combine two different areas into one, and that will become translational research, where you try to integrate two different fields, maybe you talk about public health informatics and bioinformatics together, that will become translational research, where you try to combine two areas to solve a particular problem. So these are some of the subdomains of healthcare informatics. Now I got the information that we have variety of audiences from different faculties. So what I'll do is I'll discuss some of the fundamentals of data science, and along with that, we'll try to talk about some case studies and a little bit of coding in different areas. So I'll just start with some basics. I know that there are some computer science faculties also part of the program, and they might be already knowing it. So please bear with me, right, so that we can take everyone together in the session. So it's a very basic example. Let's say red color, right? So generally what human sees and what machine sees is very different. So easily we can see that this is red color here. But when we talk about machines, basically any color is combination of RGB, red, green, and blue, right? So the combination of this actually creates this color, and that's how machine interprets the same thing. This hex code example. So same color can be represented in terms of hex, or it can be represented in terms of binary 0 and 1. And we all know that the smartphones that we use, or the machines we use, the laptops, computers, everything only understand 0 and 1, right? So basically what we are going to learn at the end is how we can interpret things in human point of view by applying some cognitive ability and try to make it more machine readable so that we can apply AI in different areas to solve different problems. Even though it's very basic, but that's how thing works. Now, if I talk about computer vision here, so let's say if I take example of a motion sensor, a camera, then that's how we interpret things, and that's how a camera will interpret things in terms of pixels, right? So if I just talk about basic definition of machine learning, so in simple language, I want to put it like we try to predict future based on the past data. And this particular tagline we are going to apply in various slides when I talk about different case studies. Even in very complex problems, this thing will be actually applicable. Now, if I just try to elaborate the same thing into some kind of basic steps, then always the first thing starts is the feasibility study, that you first what we are actually trying to apply should be feasible, right? And the most important thing is nowadays working with AI is data. So data collection, getting raw data is the extremely important thing. There are platforms like Kaggle where so many data sets are already available, but to solve a new problem, it's always advisable to create a customized data set using the available resources and then apply various informatics technologies to solve it. Now, as I talk about human and machine, so whatever data we have collected, it requires some kind of data pre-processing so that we can make it more understandable for machines. That's very important process. Before we start talking about AI and applying AI in algorithms and etc., if data is not in a proper format, then whatever we are going to work with, it's not going to really give you good results. Then the next important step is feature engineering. So we try to identify important features and those features actually which is impacting the overall outcome. When I discuss some more case studies, I'll discuss this in more detail. That's very important to design your customized model with respect to a particular problem we are talking about. We try to validate our model in terms of its training and testing accuracy. But here it's very important that a lot of AI work talks about simulation, where we talk about training and testing accuracy. But when we connect this to real-time systems, the accuracy is actually deteriorated by 15 to 20%. So it's not the actual accuracy that we get while simulating stuff. In real-time systems, it works very differently. And due to technologies such as quantum and something like models like ChatGPT, Copilot, DeepSeek, now there is a possibility that we can connect to real-time systems, which depends on some other technologies, and we can integrate AI and get better outcomes. And I'll try to discuss some of these things in the further slides. Now, just to make more interactive the session, I want to discuss some of the things. So if everybody, the audience can see this particular block diagram, where I'm trying to talk about what is traditional programming and what is machine learning. So if some of you can interpret this and answer so that we can make it more interactive, make it more interesting than just preaching. So basically, this talks about difference between traditional programming and machine learning. So if anyone from the audience can help me to interpret these diagrams.
But in traditional programming, usually we have a predefined program based upon a problem, computer processes it and gives the data and the output rather. In machine learning, usually the training is dependent upon the available data which is existing based upon a problem. So we only write the code, but we get the data from somewhere outside from various different sources. That model runs the data and then gives us a certain output. So that is why we give the term machine learning, where we have training and testing phases.
Perfect, sir. So if I ask you one more question here.
Yes, sir, please.
So what is the exact fundamental difference between these two? You explain the block diagram here.
Yes.
But if I just want to talk about processes here.
Yes.
So,
sir, in traditional
according to you, what would be the difference here?
Yes. Traditional programming, it is a predefined program. Simply, I have a problem, I wrote the program, right? So where the data input is to be asked from the user and then it works out. But when we talk about this machine learning, the data is the basis for the problem. That is the basic difference when we talk about the traditional programming and the machine learning. And then this data is executed by the model, the supervised or unsupervised, whichever model is this. And then we look into the data or the output which is given by the machine.
Perfect, sir. So what you are telling, I just try to interpret it in a simple language. Right. So in case of traditional programming, we have input as data, right? We design particular algorithm. So basically we give data, we process it and we get the outcome. right? So this is a simple block diagram of traditional programming. But when I talk about machine learning, we already know the input. We also know the output, but what we don't know is how to process it. And that is where the concept of hidden layer actually comes into play. So this is the fundamental difference between these two kind of programming, where in case of traditional, you give input, your data as input, you process it and you get the outcome. But in case of machine learning, or when we talk about different AI algorithms here, we already know the input. We also know the output that we want. But what we do not know is the processing part. And that's the fundamental difference between these two. And when I talk about this, there are four very important parameters that I have to discuss here. So that is data, information, knowledge, and wisdom. So again, if I ask one more question to audience, if anyone can give me example of data here.
A simple figure, so take an example, say 24.
Perfect.
Number. So which doesn't has any sense as such, whether it is an age, a number, a date of birth, and something like that. So it is something like raw material or something raw. We do not have any exact information about it. No relations as such.
So, sir, one more question I have, and I expect someone else to also answer.
Okay.
So let's say if I say our name, can I say it's data? Let's say our first name, right? So let's say first name or surname. Can I say it's data? So where will I put it? Data, information, knowledge, of in which category will put this? So let's make it more interactive so that I know that these are basic stuff. We will be already knowing it, but let's just recall, because these are very important things when we talk about more complex problems. Yeah. So anyone from the. Okay, so let me reply. So basically data is nothing but raw facts. So just like sir talk about number. So numbers and alphabets are actually example of data. Processed data is actually called information. So our name is actually, so from the alphabets, we actually create our name. So that becomes information. Process information is called knowledge, right? So to create knowledge, to generate knowledge, we have to process the required information that we have. And now we are moving towards the fourth level, that's wisdom, which is with decision making we are talking about. Right now, the technologies are somewhere here. So we have gone beyond knowledge economy, but now we are moving towards wisdom, right? So this is somewhere here, and this is where actually we want to reach. And future we'll see some more powerful algorithms that can actually do decision making. We talk about AI a lot nowadays. It's going to replace jobs and all those things. And I'll try to discuss more on that, why people are talking all those things and what could be the changes, because we can only predict future as of now, right? So I'll just try to elaborate the same thing into more flowchart manner, so that so let's say what generally we hear a lot about data scientists. We hear a lot about data analysts or AI engineers. So if I just stick to data scientists and data analysts, what generally they do? So these are some of the basic steps that they perform. Now it's not necessary to follow that in the same sequence. Again, it depends on the problem that you can play with the steps with respect to a particular computer vision problem or which particular problem you're talking about. So first step already I discussed is after data collection is data pre-processing. So basically making the data more machine understandable form so that when we apply different AI algorithms here, there's a good chance that we'll get good accuracy. The second step is data visualization. So in 21st century, if I talk about, let's say 2025 to 2030, the most important thing will be understanding data and managing data. People who can actually do these two things will have very successful career going forward. So data visualization sometimes, because sometimes from a particular CSV file or Excel file, we cannot understand data. And that is where data visualization comes into play. While I'll discuss some of the coding part and some case studies, I'll discuss this in more detail. But data visualization is something you just try to plot data in different forms, could be scatter plot, line graphs, right, bar charts, to understand data. The main purpose of doing this is understanding data, because before understanding data, you cannot decide which particular algorithm to apply there. or how to work with that particular problem. Once that is done, then you try to normalize data. So let's say if I talk about, as we have a session on acoustics, where I'm going to talk about audio data and how to apply AI there. So when you record different kind of audios, sometimes we have to apply normalization there. The lengths are different. It has different kind of textures and different things are there. Those has to be managed and converted or interpreted in more machine understandable form. And then we can apply data analytics there for predictive data analytics and different kind of things we are looking for. And if I try to elaborate these 4 steps into a little bit more detail for understanding, then first thing, the most important thing in, if I talk about research, is identifying the right problem. Generally, what happens is we try to give more time in designing a particular algorithm for a particular problem. So those who are pursuing PhDs or postdocs who are interested, I'll try to talk in that context, that we give a lot of time in coding and designing particular algorithm, but we give very less time in identifying the problem. And that's why I talk about some subdomains of healthcare informatics, because a lot of us carry out a lot of research in healthcare, but it's very zigzag. It's not very focused research. So if you're interested to pursue postdoc, the most important thing is learn to identify a particular problem in particular area. That also requires a little bit background information, some domain knowledge of that area, and that's how we can work. So I can give an example. So when I did a little bit research in the area of heartbeat detection, so basically working with heart failures, cardiac arrest, and those kind of things, I actually did some specialized training with AIMS doctors in India to understand that how those things happens, because I'm from computer science background, so I don't understand medical field completely like a doctor. So I had to take some extra training. So identifying the right problem is the first fundamental step, right? Where even when you are writing a particular grant or you want to work on a particular problem, this is the first and very, very important step, which I always tell my PhD students, my postdocs, that spend more time here, don't spend a lot of time in AI, because if your problem is right, you identified the right problem, then remaining steps will take care of itself. So we'll focus on the process rather than the outcome, because the process is right, and then somewhere we'll get the outcome, right? Again, the second step is data collection. So we already discussed this. And then data pre-processing, where we talk about data cleaning, right? Applying different kind of, let's say, libraries such as Panda, right? To find missing values, to scale those values, to remove outliers, etc. And then we apply exploratory data analysis, some kind of visualization to understand data, because data is always in different forms. So understanding data is very, very fundamental step for any data scientist or data analyst. And based on that, modeling this data, so designing your customized algorithm, your steps for how you can solve that particular problem, right? And then establishing different kind of communication impact, means you might want to store that data remotely somewhere on a platform such as cloud, maybe Google Firebase, AWS, or different kind of platforms. And then you can apply AI there for more predictive analytics, right? So this is just some of the basic steps, and it's applicable in every field, right? Whenever you're working with a particular research problem or even implementation problem, some of these things are always applicable, right? So these are some of the basics. Now, before I talk about some more data science, as I told you, what we'll do is we'll make it more interactive and will be more practical based, right? So we'll discuss some of the case studies based on the coding, right? So some of it actually I've planned already. So already I discussed 2 important things: data collection, data pre-processing, right? So let's see, when I talk about data, because theoretically, just like we discussed some examples of A to Z or this, right? But in real time, when data scientists or data analysts are working, the data is not actually in that form. So I've taken one simple example. I tried to use this example even in my class while teaching ML to students. So you can see I have some records of students. So the first column actually talks about, so assume that there is one admission application, right? And your input is list of students, and the outcome should be binary classification, that the student is eligible to admit based on their scores or not eligible to admit in the class, right? So first column actually talks about student is eligible to admit or not. So I've divided that into 0 and 1. So 1 means eligible to admit and 0 means, right? So Just like what we do is when students actually apply to your university, they submit their admission form, they fill different kind of data, right? And a lot of manual work is required there, or human expertise required there, right? To collect those things, pre-process it, creating Excel files, a lot of things are there. So my idea is just to discuss this example is, even though it's very simple, it has more fields and more columns actually, how we can use AI, right, to solve this particular problem and automate it. And that's where, when I talk about AI is going to replace jobs, this is where it's going to happen, right? So here we have students GRE and GPA scores, right? And then we have divided this. So we are given different ranks here, right? So 1, 2, 3, 4 based on their GPAs and GRE scores. Randomly, we are given these ranks. Now, when I say that, just like I gave first example, that humans see something differently, but machine will see the same thing very differently, right? So here we can see that these 4 columns we can easily understand. We know that we have some students data, it's GRE score, GPA score, and we have different ranks, right? Which I have given 1, 2, 3, 4. But straight away, machine cannot interpret it in the same way human can do that. And that's why I believe that in future, AI will never be able to 100% replace humans, because humans are very different with their cognitive ability and other expertise, our mind, etc. is very different. Even though we have designed AI in machine learning, which mimics our brain, but still it won't be able to perform the similar fashion that humans can do. Right, so let's try to see this. So this is basic data we have. Now let's try to process this data. Right, so first step was data collection, data pre-processing. So let's see how it works in real time. Right, so I've taken a platform called Google Colab, right, where if I simply so those who have not used, I'll just give you brief intro. Basically, you might not have high computing device, right, at your end. So how we can actually let's say run a particular very high computing. It's a very basic code, but let's say you might in future work on complex problems which requires very high end computing. So Google actually provides you this platform called Google Colab, where you can run your code on a virtual Google server, right? So that it doesn't require very high-end computing. We can run on our basic machines and we can manage these things, right? And it allows you to process different files. So you can even map your Google Drive with this kind of things, or you can even play with, let's say, different kind of mapping drives, and you can combine. So I have actually tried using Google Drive, mounting Google Drive with this. So I'm putting my data on Google Drive, right? And how I can mount that here, right? So simply, I can simply upload my file here, which we are just discussing, right? And just give you brief information for those who are not from computer science field, is there are some libraries in Python is available. It's very basic libraries, and not only computer science graduates, but anyone, right, can actually work on this. And that's why in schools, right, even 6th, 7th, 8th standard, Python is being introduced now, right? So it's not like coding is something like rocket science. Anyone can do this. It's very simple, right? So I've used 2 libraries here. So in Python, using import keyword, we import libraries. So pandas and numpy, these 2 libraries I'm going to use for this particular experiment, right? And pandas, so I don't need to write pandas all the time. I've just simply told pandas, I've given acronym as PD, numpy as NP, right? So using function called read CSV, I can simply read this particular file, right? So this is Excel file, and you can actually save this CSV, that is comma separated file, right? So most of the servers in the world, they actually understand this kind of file, and that's why we try to save this in a particular form. So generally it's XML extension, CSV, right? Or some of the different forms of text files. Generally it's being stored by various servers. Even if I talk about cloud platforms or different kind of physical servers, it stores in the similar fashion. So this basically reads this particular file, right? And here I'm telling that from, let's say I have 100 records, I only want, let's say 1 to 10 records here, right? So simply this means that, so it starts from 0 to whichever number I specify here, that many records actually we can interpret from here, right? So basically we just try to open this particular file in simple language here. Now, as I told you, very, very important things when I talk about all those fundamental theoretical steps. The 2 very important concepts are part of it is understanding data and managing data. right? If these two things we can do, then we can definitely survive for next 15 to 20 years, because that is how all the technologies are actually evolving. So now second step, so if I go back to my theoretical slide, just to correlate this. So first step was data pre-processing. Now in this particular file, the data is given and it's a simple data. So in this case, all the data has no anomalies. So after data collection, only if it is required, we actually try to perform data pre-processing, right? If it's not required, there is no point of applying that. So if there are some null values, missing values, then only we do that. So as I told you, we can always play with these steps. So even though data collection and data processing is the first step, but it's not mandatory every time to follow the same thing, depends on the problem that we are talking about, right? So in this particular case, we do not require data pre-processing, but we do need that in some other case studies. When I'll discuss that, I'll talk more about data pre-processing. So second step, now we'll move to data visualization. So basically it's just about understanding data. So sometimes what happens is here, there are only 4 columns are there, right? But there might be 100 columns or 1000 columns, right? Of very complex data file. And it's not easy to interpret those files. So easiest way to understand data is try to visualize data, right? So the same file, right? I'm just trying to visualize. So there is a library called matplotlib, right? Which is actually being used to plot this data, right? Now, one important concept called array, it's very important in any kind of programming. So basically, whenever I talk about a particular file, which is a list of records, right? When we try to represent this in terms of programming, right? We try to represent in terms of collection of these items or elements, which is basically array, right? So generally, we generally deal with two-dimensional data, right? So when I talk about images, audios, these are 2D data, right? When I just talk about basic text data, it's one-dimensional. And now maximum our systems are capable to process 3D data. In case of medical, there is a possibility of 4D as well, which I'll discuss later when we talk about those applications. But in simple language, I have every column I'm treating in terms of, let's say, array, right? So we have considered in this particular case a column called admit. So these are student data with the GRE scores and GPS, right? So simply using libraries called NumPy, I'm just treating this in terms of array, so list of elements, right? So we have GRE data, GPA data, and students, which we say that eligible to admit 1 and 0. In terms of that, we just try to visualize. So you can see there are some red dots and blue dots here, right? So this simply talks about a particular student, which is possible to admit or not. So we try to we have tried to apply this and try to visualize this just in terms of its admitted possibilities. So if students possibilities, let's say rejection, right? Then we are trying to represent that particular dot with red color. If it is successful, so as per the eligibility criteria, it's admittable, then we are simply representing this using blue color, right? So this simply gives us some visualization, but from this particular scatter plot, it's not possible to interpret this data. So that's why I told you that when we what human form and what machine form is a little bit different. So same file, what I have to do is I have to apply some more visualization here and just try to apply a little bit of clustering so that we can understand this data in a more better form. So as a data scientist or data analyst, it's very important that you keep on visualizing that data till you understand that data. So depends, every problem is different, and that's why you decide yourself with experience that what kind of visualization is applicable here or what more I can do with that particular kind of data. So in simple language, basically what we'll try to do next is, now we have these 3 columns, right, based on GRE and GPA, but you can see there is 4th column where we have actually ranked the students based on the GR and GPA score, right, where we are given some kind of number 1, 2, 3, 4. What if we try to cluster this similar data, maybe using scatter plot, into 4 different clusters for more understanding, right? So same data, as I told you, we'll just try to plot it in terms of its ranks, right? So we have 4 variables here, data rank 1, 2, 3, and 4, right? And we just try to interpret this data in terms of its rank 1 and 2, again using the same visualization concept of admitted, so rejection or successful in the similar fashion, right? So we try to cluster the same data, again applying some more visualization here. Rank 1, you can see again blue and red dots here. Same way we apply this for rank 2, rank 3 and rank 4, right? So again, if I come back to my theoretical concept I was discussing, so first step was data collection. Then if required, we try to pre-process data. And second step is data visualization. So basically we try to understand data, right? So this particular part is done. So now a little bit we can understand it in more easier way compared to if I talk about this particular scatter plot, where we simply try to plot all the data together, but it's not very easy to understand, right? So basically, and what data visualization for humans, it's not for machines, right? So basically we try to apply visualization to understand data for humans. So basically I'm talking about data scientists, AI engineers, data analysts, those people, right, apply visualization to understand data. Now what we're going to do next step is simple. We'll try to now make the machine learn. So just like how AI was designed, it mimics our human brain, right? It tries to follow how our body neural network works, how brain gives signal to different parts of the body. In the similar fashion, the similar data we are dealing with, we need to make the machine learn. So we need to make it more machine understandable form, right? So same thing. Now, instead of 1, 2, 3, 4 ranks we have given, we simply say that assuming this. So if I come back to this data file, well, let's say for this particular student where GRE and GPA score is given, it belongs to category of rank 3. So if I just try to divide this in terms of a true table, so truth table, right? So those who are from computer science might have learned something called digital electronics, right? So basically, if I just try to interpret this in more machine form, then I can simply say that for rank 1, right, it's false because it belongs to category 3. For rank 2, again, it's false. For rank 3, definitely it belongs to category 3. So I can say this is true. And for rank 4, it's false, right? So same thing to make it more machine understandable form, even though this is not machine understandable form, but this we are just trying to interpret the same record in more understandable manner, right? So same thing I can write it like this. Same way I can follow the same thing here. In case of 1, now we can simply say true, false, 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 and so on, right? So in the same way, we are just trying to interpret data. So the similar student data. So currently we have just considered 10 records, and we just try to apply the concept of truth table here so that we can interpret this data in a more understandable form. Now you know that GRE score, let's say, will be of out of something, right? Let's say 800 of particular marks. Likewise, that's how we calculate GPA. So same thing now I need to tell here. So now if you try to understand my screen, basically we are trying to convert everything into the form of 0 and 1. So if I come back to my first slide, which I discussed, even though it was very basic, but it's still applicable. So if I come back here, you can see that what humans see and what machines see, the only difference is we try to convert everything at the end into 0 and 1. That's how, right, a machine will try to interpret everything because it only understands that. That's why sometimes I say that computer is the most dumbest thing in this world because it has to, we need to make the machine learn all the time, right? That's why, even though it can, let's say, do 1 million calculations in a second, we have that kind of computers available. Or when we talk about quantum computers, it's much, much more faster, but still the basic things remain same, right? So you can see now, so we say assuming that GR is out of 800, right? So accordingly, we have calculated this GRE and we just try to convert this into more between 0 and 1 or between 0 and 1 form. And likewise, GPA. So let's say it's out of 4 generally. So that's how we have calculated GPA here. Simple, it's very simple programming. It's nothing much here, right? And already this truth table that we were discussing, it's applicable here. Now, next step is, so now this is more machine understandable form. So machine can easily interpret this false as 0 and true as 1, and it's more like 0 and 1, which we are talking about now. If required, you can even convert this into 0 and 1 form. That is also fine. You can replace false with 0, true with 1, and you can convert this into that form as well. That is also fine, right? And now next step comes is, so if I come back to again my theory, so we are done with data collection, pre-processing, visualization. If required, normalization. In this case, even normalization is not required, right? Because the data is very simple text form. So now we'll move to data analytics. Now to do data analytics, we need to move to some more steps here. So after EDA, we need to model our data, right? So we need to, while modeling, we need to train to make the machine learn what we are trying to interpret, just like we already did the data pre-processing to make the machine learn. So we try to model our data where we'll do a little bit of training of data to make the machine learn. Then we'll try to test our model, right? So same process we are doing in a simple fashion here, right? So basically, we try to train this data of 10 different records of students. So these are the training samples, and then we'll use a little bit of those samples just to test it. Even though it's a very small sample size, so it's very easy to do it. But generally, we do it like 70 to 30%, 70% training data, 30% testing data. So I'm going to take one example of handwriting recognition, where almost 60,000 records are there, right? So how to deal with those large data also in the further case study we'll see, right? So simply training the data, building your model. So in this particular case, features are technical terminologies I can talk about, or you can say columns are is converted when we talk about programming. In AI programming, we call it features. So basically, features are something which actually affects the overall outcome. So just like you want here binary classification, that student is eligible to admit or not, that kind of outcome you want, right? So you need certain features. So in your case, you consider from the given data, certain column is your features, right? And target is actually your outcome, right? So same thing, we divided this into training and testing form, right? And we just try to process it. And at the end, so this is your model. So when we talk about model, so you need to design your customized model, right? And fine tune it with respect to a particular given problem. And I'll discuss this process fine tuning more when I'll discuss handwriting case study. What is fine tuning and what is all these terms in machine learning, right? So basically, you try to design your model in such a way that you can get maximum outcome from the given input data, right? So in this particular case, if I go back to that traditional programming model and I discuss how machine learning works, so it's the same thing. We know the input data. So this is our input data that we already have. We know the outcome that we want. Now what we do not know is the processing part, and that's what we are talking here, right? So I've used some libraries called NumPy already. I've discussed NumPy already. Now, Keras and TensorFlow are very important machine learning libraries that is actually being used to create your customized model, whether it's a neural network model or whichever model you want to design, right, for a particular problem. So these are some of the Keras libraries I'm using. So I'm selecting here sequential model. So basically we are giving input, right? And then we design those hidden layers for processing, and then we'll get the outcome at that. So in this case, I've selected sequential model. Right, so there are different types of AI models are available. So accordingly, so in most of the cases, sequential model is applicable, but depends on the problem, which particular model you want to apply. So in this case, I'm selecting model is equal to sequential. Now I'm giving an input. So this is so I'm adding one layer, and this process is random. So when you first design your customized model, you do not have perfect model, right? When you start with that. So basically you start with random things, just like a neural network of our body. When I talk about your brain is connected to different parts of the body where so many neurons are there, and information is being passed from the brain to different parts of the body. So assuming here, I'm just selecting, let's say 128 neurons is my input, which I give. Now there are some, I know that there are some technical terms that is coming in the coding, which you should know already. So there are some terms like activation function. And so basically you can understand it like there is function fx, and where we are giving some input, right? And we are expecting certain outcome at the end. So in simple language, if I talk about, let's say I've selected here activation is equal to sigmoid. So sigmoid is a function which is generally being applicable when you have negative data. So if you want to deal with negative data, because its equation is 1/1 plus e raised to minus x. right? So whatever data we give as input, it will be converted. The negative values will come between 0 and 1, right? So there are different ways we try to tackle data, right? So in a simple language, let's understand it. It's our input layer, right? And then we add one more layer where there are 64 neurons. All these things are random, right? We give again activation function sigmoid. So there are different kind of activation function already available, right? And then at the end, we want our output layer. Now output neurons are 2. Why? Because we only want one outcome, whether admission is successful or rejection, right? And softmax is the go-to activation function I'm selecting for the output layer, right? And then we try to compile our model, right? So here we have selected optimizer as SGD, and the metrics based on that we want to measure this outcome is actually accuracy, right? And when I just write model.summary, it just print everything in terms of truth table for more human understandable form. Now, dropout ratio is something, it's like some of you already might be knowing, and those who do not know, basically from the given samples, we just try to drop some samples expecting that we'll get a better outcome in the future. That's again, it's a random process. This entire thing is actually a random process. And at the end, we try to, so using model.fit function, we pass on our features, our targets, and number of rounds. So there are 10 rounds will make the machine learn. When I run this particular thing, the same process will be repeated for 10 different times, right? In a batch size of 10. And and then we try to score our machine learning model, which will give you accuracy for the given data, right? And sometimes this depends on epochs as well, that you depends on a particular problem. You have to select that how many rounds are required, how many epochs are required. All those things are random, and this you can only learn with experience. When you keep on working with different problems, right, with experience, you can learn these things more. And there are a few more concepts are there working with machine learning. So there are some basic fundamentals are there, and we need a separate session actually to understand that because we have limited time. So it's very difficult for me to enter into all the details, but I'll just try to explain it in a more simpler form as much as possible, right? So this is finally a simulation accuracy we got for this particular data, right? So that's how we just try to follow this process to design a customized outcome. Now let's try to talk, so take it to another level now and try to understand this in more practical way using some real-time application. And this you can even do it with me. So if you open a portal called AQI.in, some of you might be knowing this portal, and let's make the session more interactive. And before I move on, if any questions are there on this, then I'm happy to answer. Even though it's very basic example, but I just kept it simple one first example. So it can cater to all the audiences of different faculties. Sure. So I'll just take a pause for 1 minute. So if any questions are there, you can ask, or I'll move to the next case study.
Participants, it was a wonderful session based on machine learning, data analysis, and all these steps were explained very wonderfully. If you have any questions, we can have for this session. So if you raise your hands, I'll unmute you to ask your questions. Participants, any questions which you feel to ask? You can ask, please.
Sure.
Sir, I have one question, so I'm just asking again.
Sure, sir.
We have 4 different types of learning, right? So supervised, semi-supervised, unsupervised,
Yes,
and reinforcement learning. My
Yes,
my question is regarding the reinforcement learning.
Yes, sir.
So here we have the actor, the environment, and the feedback mechanism, right?
Yes, sir.
And usually in terms of robots, if we see it performs a task, then certain rewards are generated, it is given back to the actor, and accordingly, then the machine takes the action.
Yes, sir.
Now, what is the complexity if we consider that such a robot who is working in a, say, hotel to deliver a product from, say, the production table to the diner's table, right? And
Yes,
another
sir.
robot which is working on Mars, so for collecting the samples of soil, analyzing. There is nobody, right? So what would be the complexity if I talk about of this robot who is working in a hotel and the another robot which is working on the Mars?
Yes, sir. So basically, so I can take example of, let's say, automotive systems, right?
Yes, sir.
Which pretty much use reinforcement learning. So whenever I try to work with such applications, the biggest challenge I found is because what we get here is simulation accuracy, right? So when you actually work with real-time system, the actual game changes completely, right? So you cannot just say that whatever simulation we have done here, right, is actually applicable in real world systems as well. So I can give you one example that even though it's not, but that surgical strike actually happened, right? So sir, actually, I worked a little bit in India, and actually I worked with one of the DRDO project with DRDL Hyderabad, right? So that attack was actually simulated. So it's called CFD, computational fluid dynamics. So the entire thing was simulated, and the simulation was tried to be converted into real time. But when we talk about reinforcement learning, something like automatic systems. So one of my students is working on one project where we try to detect drunken drivers, right? Those who are driving, those who are drunk. Now using computer vision, how to identify such possibilities in real time. And that's the real challenge. But I can say that ChatGPT and this kind of models are game changer now, which is making us now believe that AI can be integrated with such systems now to actually achieve this kind of outcome. So,
Thank you, sir.
if you allow me, there is one simple example I can talk about.
Yes, sir,
here,
please.
which I was going to talk about this. So when COVID happened, actually I worked with one thing, and so I designed a customized sanitizer tunnel, right, for right to so who is coming from outside, right, just to disinfect them from the different kind of infections, right? So when I did that, one more idea came into my mind that is more like the example you're talking about. So if I can find that example, I'll try to. So basically, I try to design a health kiosk, right? Because what I found, a couple of problems I found. So one thing was someone has to carry manual gun to check the body temperature of every individual who is entering, right? So
Yes.
I thought of how to design intelligent health kiosk. So when person is entering, so this actually system I installed at Symbiosis, Symbiosis of Technology Pune actually.
Yes,
So
sir.
initial system was simply it was connected to water tank and which is that liquid which is connected to ultrasonic sensor. So someone enters the tunnel, it's detected and we try to disinfect them. Second thing was before entering, that person has to stand in front of health kiosk, right? So that on that screen, person can see the body temperature live, right? And those who are not wearing face mask, that has to be detected. A complete list has to be created, and it should go to security person, so that those who are not following rules when this thing happened, we can actually solve this kind of issue. So I'm talking about some real-time example here. That so I use here Netson and Jetson AI controllers along with some sensors to convert this into more real-time system. Even though the example you are talking about, it's something for space and it's more complex. This is very simple example, but in that case also it was very challenging. So the biggest challenge is that when you work with this kind of things, the real-time accuracy that you'll get is very different from what you'll get in simulation.
Thank you, sir. Thank you, sir.
Yeah, sure. So let me come back to this case study. So any more questions, anyone? So we'll move to another case study. Now, if everybody wants to follow me, so you can open this portal called AQI.in. So it's very interesting project actually, started by Indian government. It's Indian project, and using this portal, you can find air pollution of all the cities of the world. So different regions of the world, you can simply search. Just like you can see here right now I'm in UK, so it is showing me air quality index for today. If you open this portal, it will show you your location, so particular region of Pune, and it will show you AQI here. So those who are interested to pursue PhDs, postdocs, or carrying out research in particular area, this is a good problem to study actually. That how you can actually identify limitations of the existing system and you can actually work on that particular problem to solve it. Because research is all about identifying the right problem and providing the required solution. So in this case, what this portal can do is it can give you AQI index for today, right? So today, 20th September, right now in UK, this particular area where I am in, my AQI index, air quality index is 17. And this 17, there is no formula behind this. It's nothing but a color coding adopted by certain countries, and they just try to classify this AQI in form of good weather, moderate, poor, unhealthy, severe, hazardous, like this, right? Now, if I talk about the limitation of the system, and this project actually I worked in 2009, I think 2019-20. I was very much interested. So generally, how I carried out my research is I tried to identify limitation of the existing system. I take up that particular problem and then try to work around it. So this particular portal cannot tell you what will be AQI index for 25th of September today. So today is 20th September, but in future, in cities like Delhi, this will be an issue, right? Where you will plan, just like we plan our trip looking at the weather, that based on the weather prediction, we decide where to go. Likewise, in future, air pollution is going to be a very critical factor. That's where we talk about climate change. So what would be AQI index for 25th September or 27th September or 30th September? So it's a problem here and the limitation of this particular system that you can see here. And this is when what I was talking about real time. This project is a real time. So there are more than 500 different pollution stations are connected all over India, which is capturing this data. So if you explore this, you can see these are the sensors. So one pollution station has sensors such as PM 2.5 and PM 10. These are pollution standards to measure pollution. So dust particles from the surrounding environment. Then there is CO sensor, talks about carbon monoxide concentration value, sulfur dioxide, SO2, NO2, O3. So you can see this. So combining these values, when we apply a particular formula which calculates AQI here, right? So this data is actually captured by sensors in real time. And based on that, this AQI is actually being calculated, right? And then it's classified into these forms. Those who are interested, if you just search air pollution prediction system and my name, you'll find a research paper. It's published in Sensors Journal, where in detail I talk about how these things are being done, how those formulas are being calculated, etc. Now, for us to understand here is the limitation of this system, where I cannot predict this particular value for particular date. And that was my project, which I was interested in, and I try to work towards this particular project. So what I did for this particular work, I actually try to design indoor pollution monitoring system and outdoor pollution monitoring system. So on my screen, you can see that. So this DHT11 sensor captures temperature and humidity. Then there is PM 2.5, 10, CO. So the similar kind of sensors I actually use to create my own data set, right? So there is a paper published already where all the information of this hardware is how to integrate and it's given. So basically I put one device indoor, one device at the terrace to capture this data, because always this pollution concentration values at AQI index is different inside your house and outside your house. So that is also a very important factor to consider, right? So again, the same steps you are going to follow for this case study as well. So first step was data pre-processing, then visualization, same thing I've done here, but this is real time. Now what Sir was talking about example of reinforcement learning, it was a little different application, but in this case, it's real time. The sensors are capturing this data. This data is stored on a cloud platform, and then we apply AI there for its predictive analytics. And that's what we are going to see now, right? So this system I designed where you select a particular date, and it will give you AQI values in real time for that particular date, right? So this was a small app design for that, and this work actually was carried out with some of the bachelor students actually, right? So now let's see how we can actually work with this kind of data. So on Kaggle and other platforms, this kind of data is also available. So already benchmark data sets are available, which you can work with. So I have considered already available data set for this particular experiment. And then I also created a customized data set, my own, using whatever raw data is captured by those sensors. right? So now we'll take one more complex data file for understanding. So now you can see different locations are given here. It's latitude, so it's GPS data, latitude, longitude data is given for a particular date and time. And then there are pollutants. So just like we have seen on that portal, there is NO2. Ozone is, so ozone generally when you capture, it's for 1 hour and 4 hours. This is standard thing when you want to actually work with air quality. So these are some of the domain knowledge for that. Then there is CO values are there. Then PM10 and 2.5 are the pollution standards, right, which are being used. So here the pollutant values are given, you can see, right, and its AQI value of that particular pollutant is given here. So this will be our features when you want to work with this particular file. We have all the pollutant values separately, all these columns, and its AQI values together. So combining this together will give us AQI value where this particular pollution station is actually equipped. If we explore this portal, you can even find a map where in India in which locations it's given. Let me try if I can find that information for you, because there are a lot of changes on this particular portal, but you can see even the most polluted city comparison is also given here. This project is very interesting project. It was started by our Indian government in 2019 and successfully working. And you can see all these are the stakeholders. A lot of people are involved in this. So if I can find that map, I'll try to show you that thing in more practical manner so that you can understand when I talk about these stations, these are actually installed in different locations in India. And it's very proud project for actually when I search, if you search in India, you'll see that Indian map and then you can see those things. You can explore this and you'll get more. So basically, when I say stations, it's nothing but combination of different sensors with controller is one station. Likewise, at different locations, this kind of stations are being placed and which is capturing this data in real time. It's very, very interesting project. So I can give a very good example. How in future this kind of project can be used is, let's say, just like GPS map, in future you might have pollution map. So before planning your trip, you also want to identify that on your particular route, what is the AQI value variations on that particular route. So just like we have different colors, like red color means traffic congestion, blue color, etc. Why we cannot have those color coding applied for pollution along with GPS, something like pollution map, right? So if right, so this kind of projects you can actually work with. So now coming back to this particular file, right? So we have these values for particular location with particular date and time for all these pollutants. And finally, at the end, we are going to calculate AQI. Now, already I said that there is no specific formula for AQI because it's nothing but a color coding scheme adopted by certain countries, and India also follows the same. But you can design your own customized formula. And I did for one of my research work for this particular thing, how we can calculate mathematically and all those things. It's possible, and I'll discuss that more. So again, we'll come back to basics. So two things are very important: understanding data, managing data, right? So those basics are very important. Even though the problem is very complex, doesn't matter, right? It's very important to come back to basics and follow the basics and follow the process. And as I keep on saying that, outcome will take care of itself somewhere, right? So in this particular experiment, I've used libraries such as NumPy and Pandas. And for visualization, Matplotlib, right? So we are going to apply here different kind of visualization to understand data again, because now you can see the file is a little bit more complex, where so many different columns are there and more parameters are there, right? So actual records are almost close to 40,000 in this particular case, right? So again, the same process, we try to create something called data frame in Python. So data frame is nothing but we try to create a space for a particular data. So when I just write simply data is equal to pd.read CSV, and I give input as this particular file, basically this entire data is stored in this particular data frame, right? So that is step number one. So we have collected data, we are done with data collection. And when I just run this particular file, you can see this particular data, right? So all the pollutant values and its AQI values. So as I told you, we need all these values to predict AQI. Now for this particular experiment, one thing I'm not doing is, which can be done in future, is you can consider these two columns. right, to find the data for that particular location. Now, one challenge here that you'll find when you do that is wherever the pollution station is placed, right, it will only give you AQI value for that particular area. So let's say Pune, if I give example of Balewadi, right? So Balewadi, where the pollution station is placed, it will give you AQI value for that particular area. But then you cannot say that AQI of Balewadi is exactly similar to other regions of Pune, right? So you need to have multiple stations all over Pune, right? And then find the average AQI of that area to calculate this thing. So there are some challenges involved in this particular project, and that's why this kind of pollution maps and is still not visible. But these are some future challenges. So some of you can actually take up and try to solve this particular problem. And there are different ways people have tried. They try to put this pollution station on top of their car, right? And let's say if it is 10-kilometer area, every 1 kilometer they capture the value. They try to find the mean of that, and that they consider that this is the value. So like this, many researchers all around the world have tried to solve this particular problem. Still, it's an open issue, and some of you can actually take up. Now coming back to this file. So when I try to run this file, so when I just simply run data.shape, it tells me that there are 18 columns in this particular file and 35,949 records are there. Right now, first step, if I come back to my theory again, it's very important to stick to the process. So data pre-processing, and in this particular file, a lot of records are there, and pre-processing is very much important, right? So when I talk about pre-processing, what I mean here. So let's say here you can see there are some null values are there, right? So those null values will actually affect overall accuracy, right? So there are many null values are there. There are many missing values are there. So those things has to be resolved. Like if data is like this, which is not consistent, it's not going to give you good outcome. So in this particular case, data pre-processing is required. So basically we'll try to remove null values, missing values, and there are different techniques to do that. Right. So again, depends on the problem. You select a particular technique and you try to apply data pre-processing. Right. So in this particular case, we'll try to remove null values using different functions that is available. Right. So first we try to identify that how many null values are there. Right. So for that, I've created another data frame, and where I've stored data.isNull. So wherever null values are there, I've just created a sum of that to understand that from these 18 columns, how many null values are there, so that we can understand that what kind of consistent data we have or we do not have, right? So this is very, very important. The first step, data pre-processing and visualization, right? To understand data, because still you do not understand data, there is no point of working with any AI algorithms. Now, simply what I've done is I've created one data frame where all the data is stored, and then I've created another data frame where we have stored null values. So I simply subtract this from the total data, then I can come to know exactly for a particular column that how many records I have, right? So I've used in this particular function called drop_NA to drop all the null values from the entire records and simply print those values, right? So original data of length was 35,000, but not necessary everything I can use to make the machine learn, right? So I have eliminated those inconsistent data. So there are multiple ways to solve it. As I told you, there is one more way to solve this value is we can find the mean value of this particular column and replace all the null value with that. So as I told you, there are many techniques are there. Depends on the problem, you select which technique to do. In this case, simply I'm eliminating that particular data, right? So almost 15,000 records I had to remove from the given data, and now almost 20,000 only I can consider for this thing, right? So now we have more corrected data, more so pre-processed data, right, which is available. Now, as I told you, from this particular file, what we are going to do is we are going to consider all the pollutants. So all these pollutant values and its AQI values, right, to calculate AQI. So these are basically our features that we are going to consider for our case study, right? So using again pandas, how we can call this. So there is a function called dataframe.iloc. It finds the location. So here you just need to give 0 to how many records are there. Randomly I've given 60,000, but in our case, total records are 35,949, right? So depends on whatever number of record is there, you give 0 to that. And then I've selected a particular column, 3 gem 4, right? So it starts from the index 0 and then accordingly you can select that particular column. So 3 gem4. So this particular column we are talking about dot values, right? So in this NO2 parameter, value of this particular column is actually being stored. Likewise, we have done the same process for O3 1 hours, 4 hours, CO, PM10 and PM2.5. Right. So these are all the data that we have captured from sensors, and then its AQI values. So CO, NO2, O3, O3 4 hours, PM10 and PM2.5. Right. So these are all the available values, including AQI site value for that particular date. Right. Now, first step, again, we need to understand data. Even though we have pre-processed data, so we converted data into more machine understandable form, but still we have not understood the data, because still we need to decide that which algorithm to apply here to solve this particular problem. So using matplotlib libraries, we just try to plot data here, right? So so last time we actually tried to plot using scatter plot. This time we'll try to use a line graph. So when we try to plot this data, you can see, so let's say here in this particular case, I'm trying to plot NO2 data, where I've considered NO2 and its AQI NO2 values to plot this data. And you can see this data is linear, right? And not many outliers are there around, right? So now I can easily see the data for NO2, same process, what I've done it for other pollutants, so CO, right? For O3 1 hours, O3 4 hours, and so on. So one thing is very clear from this data plotting, that's very linear. So those who already work with machine learning must be knowing that we have something called linear regression, which is very much fitting in this particular kind of data, right? So now we can easily understand data. It's very linear, not many outliers are there. So if we apply linear regression here, there's a good chance that we'll get maximum accuracy in this particular case, right? So we plotted this data. We try to do some more visualization with all the parameters just to understand data. So we apply visualization just to understand data, and it's for humans. So it's for data analysts, data scientists to understand data, right? Now, next step is, if we come back, we need to model. So now in this case, we have considered 4 parameters. So we have considered all the pollutants separately, right? So because we want to predict all these values, right, for our experiment. So we plotted data and we tried to visualize data. We tried to understand data, and we came to know most of the data is linear after removing all the inconsistencies, and linear regression is the most fitting thing here. So another experiment I also tried using ANN, but I did not get good values here, right? So you sometimes might have to try 4 to 5 different machine learning algorithms to decide that which algorithm is actually applicable here, right? So in this particular kind of data, so now next step is we need to divide our data set into training and testing. So as I told you, it's random. You can decide that 70% is for training the machine, 30% is for testing, 80-20. Again, it's random. You can decide yourself. That in my case, I've decided 1/3 size for test, right? And remaining data for training, right? So I have here NO2 train parameter, test parameter, AKI NO2 training, and AKI NO2 test. So these 4 things I have. Now in linear regression, there is a concept called standard scaler, where if required, you have to scale your data to adjust your given data. But in this case, when I actually apply scaler, I came to know that it is not giving me good values, right? So in this particular case, scaling is not required. Otherwise, there is a function called standard scaler that has to be applied along with linear regression. Now, simply when I just try to print data, so I came to know that my training data is almost 13,000 records and testing data is almost 6,000. I have considered for this particular experiment. Okay, so now we have decided that we are going to apply linear regression here. So simply I've declared linear regression algorithm here, and it is a function called fit and fit to transform basically. So in this fit function, we have passed value of NO2 train and AKI NO2 train, right? And when we try to score the model, we came to know that almost 97.93% accuracy it is giving for this particular score. Likewise, similar process we just try to follow for all. And when I try to plot this, so just in terms of, so this red line is a hypothetical line, and when I just try to plot this data, you can see it's very close to that linear line. So whichever algorithm we selected, this gives indication that everything is fine that we are doing, right? Same process we need to keep on doing with all the other pollutants. So I'm not repeating that, right? So we can save some time for some more case studies. So it's the same thing. We'll do it for CO, ozone, so O3 1 hour, 4 hour, etc. Right? So once you are done with that, right? So this is hypothetical line. Once you are done with that, the next step is you need to actually predict this data, right? So once you are done with all the pollutants, the next step is now, as I told you that how that AQI is calculated, right? There is no specific formula, but in my case, what I've done is I've considered weights of all the different coefficients, and I've designed a customized formula to calculate AQI based on the literature review that is already available. So if you are interested on my research paper, so if you just search the detailed explanation, the mathematical modeling, etc., of that particular research paper is actually, that formula calculation is actually given in this particular file, and I can briefly explain that. And then those who are interested can actually explore this in more detail. I'll simply show you the formula that how I've calculated AQI based on the available literatures. So the entire thing which I'm explaining, everything is given here, how to calculate those things and how to calculate AQI efficient. So already a lot of literature is available on this, that how to calculate those values and pollutants and etc. So that is discussed in the research paper already. Now this is the formula, right? So basically coefficient of all these parameters along with these parameters, you need to multiply to calculate the final AQI value. Right, so all this detailed explanation is already given in this research paper. You can explore more, but if I come back to the coding part, so basically the same thing, I've simply added all these coefficients. I've calculated these coefficients for every pollutant, and then the same formula I applied to actually calculate it, right? And then similar experiment I've tried with other regression algorithms also. So 7 to 8 other regression also I have actually worked with. And then I did some comparison with those algorithms also, and with some deep learning also. And based on that, finally, I came to the conclusion that LR is the most applicable algorithm for this kind of case study. And you can get maximum accuracy in this particular case, right? So before I move to another case study, if any questions are there, again, I'm happy to answer. It's a very interesting problem, and some of you, if you are working in this area, you can actually take up this work and you can take it forward from here.
Participants, you can raise your hands.
Yes.
If you have questions, I'll unmute you regarding AQI, how to calculate, the devices used, and so on, the model implemented. Any questions from the participants? Because then we will start with the session 2. Am I right, sir?
Yes, sir.
Yes.
So second session, what I'm planning is a little bit multi-model kind of data, how to work with those, and some more case studies.
Yes. So any questions from session 1?
Yeah, sure. In between, if they want, let's say some break, I'm fine. Okay. And then if they want to ask some questions, so like whatever you decide, we can go ahead.
Yes. So participants, any questions? Otherwise, we can start with the session 2. Because today we have to, as per the norm, we have to finish the evaluation part after 6:30. Accordingly, we have planned the session. So we won't have the time to extend the session as of now.
Yes, sir. Yes, and also kept some time for a question answer.
Yes.
So accordingly, what you suggested, I planned.
Yes. So in the second session, the last 15 minutes, we will keep another for the Q&A. Okay.
Sure, sir.
Sure. Thank you, sir. Thank you. So you can continue, sir, please.
Oh, okay, done.
Thank you, sir. Thank you.
Sure. So let's go ahead with the next case study. Now, in between, I discuss some concepts. So I'll briefly explain, even though I told you already that machine learning is a separate subject. So some technical terms takes a lot of time, right, to explain. So maybe some in future, some other session we can plan where I can discuss those details. But I'll just try to talk about just the basics of ANN, where
Sir,
already I discussed that. Yes, sir. Yes, sir.
sorry to disturb you, sir. So there is a question from
Sure.
Meetal madam. I'll just unmute her and she'll ask her question.
Sure, sure. Sir.
Just a second, sir. Meetal madam, you can ask your question.
Yes, thank you, sir. Good evening, sir. It's really nice to know a number of things that I've learned today from your session. Being a non-technical background, like I don't know about all these technical technology, but I am a finance faculty. So the question that I have is that a lot of research is going on ESG, environment, social, and governance, and in that sustainable investing, where certain aspects of this energy, environment, and finance are being connected. So, are you aware about any use cases where this finance integration and these the research that you're doing? Are there any alignments or use cases of this machine learning into these ESG investing and so on? So
Yeah.
that's what.
So one thing come to my mind is recently lot of recruitment in UK is for finance machine learning engineers. So just
Yes.
like you're telling. So one of the areas is stock prediction, where currently, so if you've seen that Elon Musk has designed a software, right?
Yes.
Where you can give, let's say, input as, let's say you have a bank account and you put some money there, right? And then algorithm, what it does is they've trained an algorithm which can pick up that thing, and based on the market conditions and the quarterly result of companies, etc., those are the parameters as input. It can actually do stock investment for you. So you don't need to track that thing, right? It can done that automatically, and then with experience, the algorithm will learn, right? So let's say it may be possible that first time investment happened, but the stock prices went low, right? So from that it learns, but at the end, their algorithm will give you more profit going forward. So it considers all the conditions, it learns automatically, right? And at the end, it can actually do stock prediction for you. So the entire portfolio management for you, it can be done using algorithm. It's already available. This software is also already available. And recently in India, if I talk about, there is this app called Grow. It also makes use of AI.
Right.
If you tried. So I mean, this is one example in terms of stock prediction. Likewise, if I talk about energy, so energy also green technology we hear a lot nowadays, right? So here in UK there is a concept of smart buildings, where I mean environmental friendly, different kind of sensors are connected at different places, and they're making sure that the overall energy consumption can be reduced. So just like in India, it has started that every house has now solar panels, so that your air condition bills and all those things will be reduced. Likewise here, how we can have more optimized energy usage and how we can pass on that energy to different areas, that is actually going on here. So, and that kind of energy can be used to, just like in India, there are areas still where energy requirement is still there and it is not reached completely. So this kind of energy can be utilized there. So definitely the area you're talking about, I'll name it as sustainability, which is 2030 UN sustainable goal also, where a lot of research, I mean open research issues are there in this area also. So nowadays it doesn't matter you're from which field. AI will be part of every field in future. So, and as I told you, it's not rocket science. All these things you might look right now, you feel like maybe you know some things, you don't know some things, but it's not very difficult. Once you start working with it, you can actually work with it. Doesn't matter you're from computer science or not.
Yes. Today I learned about it, sir. I felt that it is doable and I would be able to do. So really thank you for sharing all these use cases and case studies. Showing steps was really essential for people like us. We could visualize actually what can be done. So thank you so much for that, sir.
Sure. So if I just share my example, I did my PhD in IoT, right? So in our area, IoT and AI is like mechanical engineering and MBA. It's different. So I had to really learn AI to switch myself from different area to different area. Exactly. So if right, so it's same for everyone. So you can do
Exactly.
that. And
Yes.
sure. So
Thank you, sir.
Thank you.
Sir, there is another question from
sure,
Mr. Manoj Mahanubhav.
sure. Sir.
His question is, how much we can believe these AI apps in conditions uncertainty like war, flood, or any complexity in stock market?
So, sir, actually, you can believe. Sir, if you know this particular thing, right? So, Notepad everyone is using, right? Sir, I can give you one app name and you can try yourself. It's called Notebook LL. So, Notebook LM it is called. It is based on LLM model. You can try this. So, recently, actually, I installed that in my Apple laptop, but recently what I did is actually I got my medical reports, and you know that we can't understand every terminology. So what you can do on this particular platform is you can upload different files, right? Let's say you have 10 files of your medical reports. You can simply upload it here, and just like you go to ChatGPT and ask questions, you can simply ask questions to this particular app. And this will give you information. It will process information of those files and give you predictive analytics even for that. So that's how I actually process my medical reports so that I can understand certain things which I want to understand. So these things are not vague anymore. That's why in the session I talk about simulation accuracy and real-time accuracy. Simulation is something that could be vague, but when we talk about real time, it's actually going to happen. So right now, so recently I visited India last month only, and I realized that not every corner people are actually talking about AI. But if I talk about UK here, people are really worried that they'll lose their job. So even if I can talk about professors who thinks that there'll be no need of degree in 2030 because everything is available and AI can do a lot of things. So then how we will play a role somewhere, even though I still believe that we still have a role to play and we still have skills to sustain along with AI. But this is going to happen. A lot of things are going to change. So we cannot just consider it's vague. It's actually affecting our life. So you can try this app. You can try this on your own.
Thank you, sir.
Sure. Even if I talk about my university, recently we have actually collaborated with Claude AI. So now for our students, they are allowed to use AI in their assignments, right? So among certain percent of plagiarism is allowed now for them because we cannot stop AI, right? So we decided that we'll not stop students as well. So we thought that how we will design our modules in a better way, that along with AI, so we make the use of AI and how we can actually use them. So we have to work with AI. There is no other way.
Thank you, sir. Sir,
Sure,
just
sure.
I'll disturb you for a second. I request
Sure.
all the participants to switch on their cameras. We will have a group photo today with sir and all of you. Please switch on your cameras. सबको अलाउ कैमरा करना पड़ेगा.
Sir, now how many minutes we have left?
Sir, we have 1 hour 15 minutes, sir.
Okay, perfect. Then it's perfect.
I have switched on the cameras for all. You can please switch on your cameras. I request you so that we can have a group photo. I have allowed cameras for all. Please check in. The camera is allowed for all. For a second, sir, can you switch off your screen sharing so that we can have the...
Yes, sure, sure.
Yes. Thank you, sir. Yes, thank you, ma'am. Please, I request each one of you to switch on your cameras. I am also switching on so that we can see each other. I request each one of you who is possible to switch on the cameras, please switch on. Thanks all of you. It's great to see all of you on screen. I thank each one of you who are present on the screen. Thanks for making this session so wonderful, engaging, and participative from all of your sides. I request sir to continue for the next session.
Sure.
Thank you, all of you. Thank you.
Right. So before I begin the next case study, what I'll do is some of the terminologies which I could not explain. So I'll just try to give you some information on that. And that will really help you, those who want to take up AI more in detail and those who are not from computer science. Right. So already I discussed that how AI model is different from traditional programming is. We know the input here, we know the outcome here, but we do not know how to process it. And that is what is called hidden layer. So how that thing works actually, how to decide, because I keep on telling that everything is random. The modeling that we start, we try to code everything, we select randomly. So then how this thing will work? So let's try to understand this particular part. So I've taken one example, simple. Let's say, so this is how every neuron will be tracked. So if it's you're working on something on computer vision, so this is simply example of face neuron. So this is how neurons actually keep on communicating. And those neurons in this case are just mathematical functions. So when I talk about human body, these are actual neurons. But when I talk about neural network or machine learning, the neurons we talk about is nothing but a mathematical function. That's why we call it artificial neurons. Those are not real neurons, right? So assume that your algorithm is one function called fx. So this I've taken an example of activation function, right? So there was something called sigmoid when I was discussing. So there are different activation functions are there where we give input and then we try to get the required outcome. So in this particular case, assume that fx is your algorithm, right? And as you already know that you know the input, you know the outcome, what you want, but what you do not know is the processing. So how to take care of this? So randomly, I've selected some input here in this case. So let's say weight 1, weight 2, weight 3. These are the random inputs I'm giving to this fx, and assuming that at the end, so let's say, so this is our input data, and our first case study. So let's say our outcome is binary classification 0 and 1. So I give some input here, right? So I initialize some random weights. We try to process it in our hidden layer, and the outcome we got is 0.8. Now we already know that the outcome we are looking for either 0 or 1. That means the algorithm requires little bit of adjusting, and that adjusting is called fine tuning. So it's a fine tuning is a technical word in machine learning where we just try to adjust our input that we have taken so that we can get the better outcome. So let's say we give some other input and now we got 0. So that is fine because either it should fall into our class close to 1 or 0. That is what actually we are looking for. Now let me give another input. So now we process it and I got 0.9, which is very close to 1. But we'll try to again find the possibility that can we reach to 95% or 97%, 98% accuracy, right? Because we want to be close to 1 either or close to 0. So again, and you can see here there is an error of minus 0.1. And that is where error function comes into play in coding as well, that we try to reduce this error to minimal value possible. And this entire process is actually called fine tuning. And that's how we try to train our algorithm while training data, right? So this modification that we try to do is actually fine tuning. And we keep on doing this till we get value close to 1. Right? So it's not an infinite process, but you try to reach to the outcome close to 1, and that is where you stop. And as I told you, with experience, you'll get this idea where to stop, how many neurons to select, all those things that will come with experience. But that doesn't mean you should not start. You can start with random values, and along the process, you'll learn more. And that's how we can work with AI. Right? So here, let me take one example of handwriting. It's a very good example where we try to classify digits 0 to 9. Now, as I told you that basically neural network is nothing but, or AI is nothing but, it mimics our brain, right? So basically the way we studied when we were very small, in the similar fashion, AI is going to study. So if we come back to our school days, when senior KG, junior KG, when we try to learn these digits, so what will come to your mind is standing line, slipping line, slanting line, circles, etc. Right? In the similar fashion, we are going to make the machine learn. So what we'll try to do is from these 0 to 9 digits, we'll try to divide this into clusters of similar digits so that we can make the machine learn. And from those digits, machine can easily classify between 0 to 9. Again, the same process. So we have input layer, we have hidden layer, and the output layer. Right. So assuming there is digit 9 here. So what we try to do, we consider digits with standing line, slipping line, and slanting line and circles. Right. So you can see wherever these lines are available, we just try to match those lines in different digits, and we try to calculate weights for every digit. And that's how machine learn, because as I told you, human can easily understand and classify 0 to 9. Machine cannot. We have to convert everything in the form of 0 and 1. So basically those are weights. Weights are between 0 and 1, and that's how it will try to understand. Right? So same process. So what we've tried here, let's say we consider vertical lines. So vertical lines, we got digits 1, 4, and 9. So we can cluster 1, 4, and 9 into one. That there are digits with vertical lines are available. Now there are digits with horizontal lines are available. So we have 7, 2, and then 0 as well, but 0 could be classified separately in terms of circle as well. And then digits with small circles. So maybe 0, 2, 6, and 9, where small circles, and even 8 in this case can be considered. So likewise, we try to divide this into clusters so that machine can easily understand this. Right? We can basically try to divide complexity, reduce the complexity by dividing them into more clusters. Right? So now in terms of machine form, what will happen again is this is human form, but this will be converted to some kind of array, which is machine readable form. Then it will be input to our algorithm, and at then we just try to classify between 0 to 9. That's how it's going to work. Right? So for this particular example, I've considered 28 cross 28 images, 60,000 images called. So there is a widely known data set called MNIST, which has all these digits already available. Right? So let's understand how this algorithm will work. So we are trying to design our customized model here. So we are selecting the model as sequential because we have input, we have some hidden layer processing, and then outcome we are looking for. Now randomly, so already this input already we know 28 cross 28 images of digits 0 to 9, right? And the number of neurons we are selecting randomly. So in this case, we selected 500. Now this figure, as I told you, it's random. And based on the outcome, we'll decide that we have to do fine tuning or not. We need to customize our algorithm or not for a particular problem. And we keep on doing that till we get the most optimum outcome. We have added one more layer. Now this input, we give it to activation function called sigmoid. Just like I explained that FX process, it works in the similar fashion. Right? So these are some more activation functions available. It's already inbuilt, and this is nothing but these are different mathematical formulas, just like 1 upon 1 plus e raised to minus x. Likewise, there are multiple functions available. It has its own significance. Just like I talk about sigmoid, it's very good in dealing with sigmoid data. Linear is very good in dealing with linear kind of data. Likewise, there is 10H. ReLU is also very well known go-to function. Generally, we select ReLU. while we are adding those layers. And now we have one more layer. Now again, how many layers will be there in your algorithm? That is also random. So nothing is fixed here, right? So, but we felt that samples are many, so at least 2 layers are required. So that hidden layer is not necessary, it's just one. That hidden layer could be 100 as well, right? So you already know the input, the output, but you do not know the hidden layers. How many hidden layers? That is also you randomly you decides, and how many neurons, that also you decide randomly, right? So again, we have decided 500 neurons. So 500 neurons will give outcome to another 500 neurons, and these are nothing but mathematical functions, just like we discussed. And but what we know is the outcome. So now we know that how many neurons we need in outcome. So we want classification 0 to 9. So how many? 10, right? Starting from 0, 1, 2, 3, 4 to 9. So we know that output neurons will be 10. So what we want as outcome is either 0, 1 or up to 9, right? And the activation function at the output layer is softmax. Same process it will follow, just like I discussed. So first step is defining a set of function, which we have done in this case. Now we'll keep on doing fine tuning. We'll select this random values if required. We'll change 500 to 512, 250, 1000, etc. We'll keep on doing this till we find the goodness of function. That is most optimum algorithm that is giving you good outcome. Right. So we keep on doing this. And now you know the process. We try to minimize the loss as much as possible. And using loss function, we try to capture the loss. Right, so whatever loss percentage is, that is captured using the function called categorical cross entropy. Now, in this case, I'm applying categorical cross entropy, but there are again many options are there. Again, depending on the problem, you will choose a particular function. Now, there are many optimizers available. Adam is the most go-to optimizer. So if you do not understand much, just straight away go for Adam. But there is Adam, there are multiple optimizers also available, which will give you more optimum value at the end. Right, and the metrics based on that you want to measure this. So in this, generally we select accuracy, but there is also F1 score and there are sensitivity and there are multiple options available in metrics. Also, we go for accuracy in this case. Right now, so using model.compile, we are going to compile our neural network model, and we capture the loss using loss function, and then we right. So then we try to find the optimal parameters from this. So as I told you that every data set has to be divided into 2 parts, training and testing. Generally, we keep it 80-20 or 70-30. So 70% training we do, we make the machine learn, and then we try to test the machine that what kind of outcome it's giving using validation. So model.feed function will help you where you pass your training parameters for X and Y values in this case, because we're considering 28 cross 28 images. So it's a 2-dimensional data. Right, and then we try to process this. So batch size is optional. You want to process this in terms of 100 batch size, or you can just decide how many rounds you want. So in this case, we are selecting 20. Again, depending on the problem, you decide. So this training data, labels we have, and the number of rounds so epochs that we want to process this. Right, so this training data is nothing but everything is converted in terms of arrays of 0 and 1. Because you know that machine can only understand 0 and 1. So everything has to be converted in that form. So both are our NumPy arrays, and then we process it. Right now, using model.evaluate function, we try to validate our function, that what accuracy we are getting, because we have trained the model now, but we do not know that. And generally, we consider at least above 85%, 90% accuracy is a good accuracy. Still, it's a simulation accuracy. When you connect to real-time system, it changes a lot. So that also has to be considered depending on the application. So using this function, we try to test our model using X test and Y test, and this will give you the actual picture and how things are working. And using model.predict function, we can actually predict a particular value. So in case of that air pollution case study, this can give you prediction for AQI or particular pollutant that you are considering. Now, as I told you, batch is not necessary, but you can process everything in terms of batch so that you can get more organized outcome, but it's not mandatory. But you can decide that you want to process, let's say you have 40,000 records, you want to process in form of, let's say, 5,000 batches or 100 batches, or depends on, again, it's your choice that you want to go for that or not. But again, it depends on the complexity of the problem. You decide this particular thing as well, right? And then next thing is, so there is one technical theory in neural network works is called backward propagation. So basically, once you read that, you'll understand that how those neurons actually pass on information to different neurons. And there are two important parameters comes into play is bias and variance, right? So always this algorithm has some bias, which we have to reduce, as well as it has some variances, which we have to reduce to reach to the most optimum outcome at the end, right? So this was about handwriting algorithm, right? And I can just give you some information. So I give you some demonstration on this, and then we'll move to acoustics. And in between, if any questions are there, I'm happy to answer. Right, so this is a very simple example where we have divided. So this MNIST data set is already available. As I told you, it has 60,000 samples. So it's already available. So simply what I've done is from Keras dataset, I've just imported this particular dataset of handwriting, which has samples of 0 to 9 different digits, which is size is 28 cross 28. Right now we have divided this dataset into training and testing form. So we have xtrain ytrain parameters, xtest ytest, and we load this particular dataset using load.data function. Now, actually, these images are color images. Now, just like you know that in computer vision, we try to convert everything into gray so that we can apply mathematical functions in a better form. So what we are going to do is using IAMShow function, we are just going to show what is this xtrain 0. 0 means the first sample I've considered. So I just write 500. So from the data set of 40,000, it will consider the 500th value. So that particular image will it will pick and will display here. So this function will simply, so plot.cm.binary will convert this form into black and white form, which is more understandable form. Again, this is human understandable form. We have to convert everything into machine understandable form. So we have to again convert this into array. So now you can see the same image is converted in the form of array. So as I told you, machine is the most dumb thing. We have to convert everything in the form of 0 and 1. Now we try to design a customized model. So we selected sequential model, right? And now input layer. So there are different ways. So there is a concept called flatten layer. Right now it's difficult to explain you, but you can say that you can keep some value in the input layer. You can keep the flat layer. So there are some options are there. Generally, we try to keep our input as flatten layer, and then we try to add hidden layers. Again, this is random. So randomly I've selected 128 neurons, and the activation function is ReLU. Again, 128. So 2 layers I'm adding here with activation function ReLU. And then now you know the outcome already. So you know you want 10 neurons, right? So 0 to 9 digits you want as the outcome. So 10 neurons outcome, and the activation function I've selected is softmax in this case. Then simply you compile your model where this is the loss function. Using that you are capturing loss values, and the metrics you are going to measure using accuracy. So when I just try to so using model.fit, I've trained this data. So data of MNIST data set, and whichever part I've divided into training form that we have trained, and you can see we got accuracy. So first round, so first epoch, you can see accuracy is 86%. The second is 96, and third is 97. So when you train model more, you get better accuracy, and it reduces your loss as well, right? And then using model.evaluate, we pass the testing parameters to score your value. So the accuracy is 96.82, which is good accuracy, right? As I told you, it should be above 90%, 95%. Nowadays, it's even 98, 99% is maximum. Again, it's a simulation accuracy. When I connect to real-time system, this will reduce a little bit, right? And then, so this particular model is now ready for handwriting recognition, right? So this example is also given on Keras platform, where the basic code is also given, an explanation, everything is given. So you can try to explore from there, those who are not knowing this already, right? And now we'll move to another case study. Now we'll talk about how we can work with multi-model data. So we'll work with images and text. Now we'll move to acoustics, which is my current research area for the last 3 to 4 years. I'm working in that domain. So before I move, again, if any questions on this, I'm happy to answer. and then we can move to the next thing. So if any questions are there, sir, even in the chat, then if you can help me just to see that. And
Madam, mic is allowed for you. Prapti, madam, you can ask your question.
Yeah, sure.
Prapti, madam. Madam, okay, you can type your question. I'll read it for you. Am I audible, sir?
Yes, you're audible.
Her question is, what are the filter in the CNN algorithms? As per I know, filter are edge filter and so on. Is there something else rather than this filter?
Okay, so in this case, I've used actually ANN, but in case of CNN, actually it works little differently. So I can talk about it actually. But briefly, I can talk about, because in detail it's difficult to cover everything now. But I can simply talk about how CNN works in some way. So, ma'am, just for understanding, I've taken one simple example, of CNN here. So now you already know that input is basically when I talk about images. So it could be 2D, 3D. Black and white image will be 2D array, and colored image will be 3D array. That's how machine will interpret it, right? So generally, you give your input, and then based on that, you try to do feature detection. So again, you already know that which features you want to get certain outcome. So that process is known, but from this, let's say we try to calculate this. So this is your input image, is nothing but your array. And from this, we try to build feature detector, and then we try to actually create a feature map. So from this values, you can see we keep on finding these values. There is a formula, right, to select these values. And based on that, for every feature, we actually create a feature map, something like this. So if I take simple example, for every input image, these kind of feature maps are actually designed. So you can see there is collection of feature maps here, right? So CNN works little differently from ANN. CNN is specifically designed for computer vision problems dealing with images and this kind of more, I can say that image processing and this kind of problems. CNN is specifically designed for that. So you can see this my slide, and it explains you how it's calculated. So that's how you actually design feature maps, and which would be your input to your input layer. Now I know that I've not explained this in very detail, but this is how it works. And then these feature maps are different for every image. So for example, you can see there is a Taj Mahal image, right? So based on that, this is its calculated feature map. And based on that, it decides that it's a sharpened feature. The age enhancement is there. Likewise, different kind of feature maps are actually designed. And that's how the algorithm is also designed, which has this information already. Right, so and there are different variants of CNN is also available, like MobileNet, AlexNet, different kind of that. There is a computer vision competition happens every year when someone comes up with a different variant for a particular set of applications, right? They've been awarded runners up and the winner, and that's how the new model is named. So initially, so CNN actually is actually designed by Jan LeCun, who is actually a PhD student of Jeffrey Hinton. Right, so his PhD was on CNN. That's how we design it, and as I told you, it's specifically based on this. Right, so for blur, you can see it's a different feature map. Now, CNN has layers called convolution layers, and this is an example of convolution function. Now, I can't explain right now in very detail, but I can simply say that there are two parameters important is F and G. So these two functions are important. Based on that, it's calculated, right? And it has some concepts like convolution, cross correlation, autocorrelation. I'll try to have another session and I'll discuss this in very detail. But simply, you can simply understand this from input image. It creates different feature maps. And finally, this will be your input image. So those feature maps are your input, right? And your feature detector, as I told you that it's you're dealing with color or black and white accordingly, it will give you different values. And the next thing is the max pooling layer. It's very important. From the different feature maps you would design, right? Now, let's say you can see here, lion is standing, right? Here lion is sleeping, and there are certain things, certain frames that you do not want to consider, and you want the most optimum outcome. So this pooling layer actually comes into play here. This helps you to have more critical outcome at the end. That's how the algorithm is designed actually, right? So basically from feature map, what we do is we consider the maximum value from the squares and we design a pooled feature map, right? So that's how we, from the feature map, we actually design full. In case of CNN, this is not applicable in ANN. So I'm talking about CNN in this case. And then now you have input images, you created feature maps, and you have pool feature maps. Now you have your flattened layer. So you try to divide this into more flattened ways. So you can see in terms of matrix, this is now divided into this form. It's a flattened layer, it's called. So same thing is divided into flattened. Now these are just random values, but for machine, it's something just like I explained that for a blur value, for sharpen value, for this, that, everything machine can understand from these values actually, right? So now you have input as your flattened layer. Then there is something called fully connected layer, where you decide your hidden layers and number of neurons that you want to give. So you add your convolution layers here. And let's say in this example, let's say I want to classify dog and cat. It's a very standard example, right? So from this, it processes. So now what happens is these neurons keep on sending weights to different neurons. Now you can see here, this output neuron is connected to these values, right? Now you can see here 0.9 is close to 1. It's 1, it's 0.2. So from this, let's say dog is 1 and cat is 0. So likewise, the outcome is selected, and that's how the classified outcome will come from here. Right. So let's say input I'm giving here as dog. All those processes happened, feature map, pool feature, everything is created, right? And at the end, the value you can see you got 0.95 means dog is the outcome, and 0.05 is for cat. Likewise, this will keep on changing based on the weights that is communicated between the neurons, and that's how it works, right? And then here the concept of activation function comes into play, right? Where I won't be able to discuss this in very detail, but simply it has something called a value of true probability and your predicted outcome. So PX is the probability and this is the predicted outcome. So predicted outcome in this case is, you know, that is here. This is your predicted outcome at the end. So that's how this calculates these values. So in this case, let's say if dog is 0.9 at the end, which is connected to output neuron. So that value will be assigned to Q here, right? And what we want, dog is 1 in our case. So your P will become 1 in this case, right? And likewise, it calculates so that cross entropy functions and everything we discussed, it calculates like this. This is another function called category cross entropy. So same process it happens, and finally you get the final outcome. So I hope that I explained a little bit what you asked for. So this is the entire process how CNN works.
So there is another question. Can
Sure.
we use ANN or primary records of 1,000 records on primary data of 1,000 records? Sorry.
But with images he's talking about, or
not specifically mentioned. Bijal madam, can I switch on your mic so you can ask your question? Sir, there are no images, simple records without images.
Yeah, then you need to decide even machine learning, because let's say you use ANN, but it may be possible that for simple records, even machine learning will give better outcome. So we have to try 3 to 4 different algorithms finally to decide to come to the conclusion. Again, based on the processes I discussed, that we need to follow the steps to finally decide that which algorithm is applicable here. Because there are more than 100 machine learning algorithms are there. There are few deep learning models are there. Even in case of, let's say, CNN, there is something called MobileNet, AlexNet, right? RaceNet. So from those variants also we need to decide based on the application which is more fitting. So ANN can also work with computer vision. So I've used ANN multiple times in some of my projects where ANN is giving me better outcome because it's more simpler problem and I can actually apply it. But something like, let's say, object detection, then even CNN will not give you very good outcome. Then you have to select some advanced algorithm like YOLO, which is specifically designed for object detection. Or let's say if you want to work with face detection, there's something called FaceNet, right? So likewise, for every problem, you need to choose the right algorithm. So it's not necessary that this can be applicable, that can be based on the experiments only you'll come to know that which is more fitting there. But obviously there are some basics of every algorithm. So we know the basics and accordingly we choose. If it's computer vision, I'll definitely go for CNN or some variants of that or some advanced algorithms of computer vision.
Another question, sir. What is softmax from Prapti, madam? What is softmax?
So it's an activation function. So
thank you, sir. Thank you.
So I'll just try to explain that.
Okay.
So it's nothing but basically just like I explain you this thing. So that dog example was good, where that calculation I explained. I don't have the softmax example, but basically it's a mathematical function where you give input and then you get certain outcome based on the. So every activation function has particular formula, just like I'm talking about this one. So yeah, I got the softmax thing here, right? So you can see this is the mathematical equation for softmax where you give your input. So Z is your input vector, right? Your e raised to Zi is your standard exponential function for input vector. Right, so for the given input vector, this is your exponential function. K is the number of classes in the multi-class classifier. So in our case, dog and cat, so only 2 classes we are dealing with. So whether it's a binary classification problem or multi-class classification problem, that is specified here. E raised to Zj is standard exponential function for output vector. So these are, so you already know the outcome as I keep on telling. So in this case, you know that you have 2 neurons for the outcome. So e raised to Zi represent this exponential function for output vector, and Zj actually is again for output because there are 2 in this case. The Zj means in our case there are 2 outcomes, so 1 and 2. If digits 0 to 9, then that will be 1 to, I mean 0 to 9. Likewise, it will work. Right, so this activation function is nothing but it's a mathematical function, right, where you give your, because what happens is your input data is not images actually. Your machine interprets it in terms of array. So to calculate array, to process array, you need mathematical functions, right, and correlating that with your final outcome. That's how it works, and that's how these algorithms are designed. So you can see this example here. So as you now, how this output neuron is decided, as I told you, is it depends on the connected neurons. So whatever the values connected neuron has, based on that, it's decided that it's close to 1 or 0. And that is, and in this process, this activation function actually helps us. That's why it's designed like that. Because everything is designed based on the concept of probability, right? So probability means it's not black and white kind of thing. It gives you percentages, just like you get accuracy 95%, 97%. That's how these algorithms are designed, and that's how it's working. So I hope I've explained a little bit, ma'am. And if any more question you have, I'm happy to answer. So, sir, any more question, or shall I move to the next thing? Hello, Chocolate sir. Any more questions are there, or shall I move to the?
No, sir. You can continue with the session. The questions are over.
I hope ma'am have understood. I tried to explain whatever I could, and
yes.
Sure, sir.
Thank you, sir.
So,
Thank you. Thank you.
yeah, sure. So the next case study is actually is interesting one, and as I told you that I try to find some existing systems and try to find the limitations, and I try to do research on that particular thing. So I was very much interested in finding that, uh, and why I started working in the area of acoustics, because I thought that a lot of problems camera can solve, but I felt that camera cannot reach everywhere. So if I just take simple example in a house, we don't keep camera in our bedroom, right? We don't keep camera in our washroom. So what about those events that happens in certain locations where camera is not available? So how to track those events and how to classify those things? That was my interest area. So basically I wanted to replace camera and find alternative way how I can work with it. So I started working with acoustics there. And another reason was, as I was working in IoT, so one challenge I was facing was whenever I captured data from different sensing units, the data aggregation was very challenging for me by storing on cloud. So I had to really pre-process data and convert into certain form before I start applying AI there. So in case of acoustics, what I found is I can use similar set of sensors, I can capture data and I can apply AI there. So it's more easy for me. That is also another reason that I started working on this. So as the title indicates, I try to actually capture some of the ignorant noises at house. So I actually capture noises of tap water leakage, flush water leakage, cupboard noise, different kind of radio noise, television noise, different kind of noise, just to capture correlate that with a particular event. So let me give an example. So let's say if there is a tap water leakage or gas leakage somewhere, because gas leakage is also some kind of audio signal, right? So this kind of leakage, water, gas, and electricity, right? This kind of critical parameters are very important. So we are very busy in our life that such events we cannot capture, and finally it will affect critical resources such as water, gas, and electricity. So there is a gas leakage, and if it is not captured, then it might result in some kind of accident, right? Or if there is tap water or flush water leakage, what will happen is your water tank will be completely empty, right? And it will affect your daily routine, lifestyle, everything, etc. So I wanted to capture those ignorant noises and then correlate with different events. Example, cupboard noise. Now we don't keep camera in our bedroom. Our intruder has entered our house, and based on the cupboard noise, if microphone sensor detects this noise, and it will notify the house member that some kind of event has happened or some intruders actually entered the house. So this kind of events actually we can capture using such ignorant noise. That was the idea. I wanted to work on this particular case study, right? So I actually designed a customized framework actually for this. So now how audio works compared to computer vision is actually concepts are similar. So in case of computer vision, we convert color images into grayscale and then we apply some mathematical functions there. In case of audio also, we convert this into grayscale image, which is called spectrogram, and then we do that. Let me show you one example before I move on so that we can understand this in more better way. So let me open Google Colab. Right. So what I've done is the problem I'm discussing, actually I've created a customized data set for this different data that I've captured. Right. So you can see chair movement, curtain close, open noise, door open, close noise, fan noise, flush noise, freeze open, close noise. So likewise, 22 different activities I've captured for this particular experiment. And let me show you one example that what happens when we deal with audio. So there is a library called Librosa. It's already available in 2019. Actually, this library came in the picture. If you want to apply AI in audio, then it was very complex because it's more about signal processing. So you have to apply analog and digital signal processing techniques, depending on which sensor you're using, analog or digital. And then you have to integrate that with AI, which was very, very complex process. But since 2019, since these libraries came, everything become more simpler. So this Librosa library is certain code. It's a music library, which has different filters available to apply to different kind of audios to extract more information. And I'll discuss that how to do that. So let me select one simple audio here. I'll show you how this thing works in reality. So let's say if I go back to one of the audio file. So in this case, let's say I'll consider water noise, right? So water leakage I've considered here. right? So for my code, again, you know that matplotlib is for visualization. So we need to understand data. That is the first step. And then we need to know how to manage data, right? So I will put a librosa using numpy library because everything is terms of 0, 1. So I have to do that, right? So simply I run this and then I try to run this particular file. Now you can see that this file is in waveform. You can even capture this in MP3 and you can work with this particular library. But my suggestion is convert MP3 even into waveform. It's a wavelet transform form, which has already some techniques, digital signal processing techniques are available, which will help you to extract more information. So if I process this water noise file, you can see this is actually grayscale image of audio. So this grayscale image in this case is a water noise, right? Now what is happening here is I cannot extract much information here. So it represents hertz, so frequency here, right, in terms of dBs, and that's it. And I can see some frequency components here. So some high frequency components and some low frequency components, but it's not giving me much information. So what has happened in this library is this library has more than 200 filters. So with respect to a particular problem you are taking, you have to select those filters and you should try to extract more information. So it's all about, as I told you, data, information, knowledge, wisdom is the same thing we're talking. So let me try to do that. So the same sample I'll try to use. Now, before you select a filter, you should know that the significance of that filter and how it is correlated with this particular problem. So that information I had, so based on that, I choose a filter called poly features, which will give me information. Right, so we just try to. So there is one limitation of this platform is it only allows you to use certain sessions. So so parallelly, it will not allow you to use many sessions at the same time. So now I think we can do that. So now the same file, audio file, I'll select here. Give me a minute because it's connecting. So as I told you again here, you can even use Google Drive here. You can place your data in Google Drive or even in physical machine locally, and then you can give that particular path and you can choose that file. So yeah, so it's not helping me. Let me try one more time. As I told you, it requires a little bit of high-end computing working with audio, even though we are running this on Google server, but it also requires minimum amount of computing even on your computer. So give me time. Because what happens in audio is it has a large length, right? So the computing and processing. So now it's done. So let me select the same audio file. So water noise I'm selecting again, and let's try to run it. So now what I'm doing is I'm trying to extract more information from spectrogram, which was a grayscale image. So you can see here, this poly features will give you information of different orders. So order 0, 1, and 2. So basically it will try to give me different form of information. Once I run it, you'll see more. And then we'll try to understand the code as well. And these code snippets, the basic code snippets are given on that library. So if you simply search Librosa machine learning, right, you'll get these filters and libraries. It's already available since 2019. So this documentation is already available where information about the different filters, how, right, it's already available, a bit of code for particular thing. All those things are already given. Right, so you can actually use those libraries. So I can give an example. So let's say in this particular case, you can see a bit of code snippet is given. And it is given some information that this, but you should have some knowledge about what this parameter means and what those things means actually. So that requires a little bit of signal processing knowledge as well as a little bit of knowledge of audio. Right. So now you can see I got two class classification. So I got representation of the spectrogram of water noise in terms of quadratic form, linear form, and constant form. Right. So you should have some domain knowledge to understand what this means. Right, so just for your understanding, I'll use one more filter, which is more simpler to understand. So basically what we're trying to do by applying this filter is we're just trying to extract information. Simple. Let me select again the same water noise sample. Let me run this. Now this extracting information is very important. It's kind of pre-processing in audio. Here we are going to decide that which samples we can actually train the model and which samples actually we need to discard. So this is very, very critical in case of acoustics, that if you give a certain sample with certain noise or certain anomalies, then you'll not get good outcome here. Because audio is not like you're going to get 95% or 97% outcome. In audio, you get it close to 80% outcome because it has noise, attenuation, it's a signal processing thing. So it's more complex compared to just working with text data or image data, right? So you can see this gives me, and you can see the computation time it takes to compute this. So this gives me information about onset strength of this particular water noise. So I'll call it in technical language signal. It's nothing but audio, but it's actually a signal, right? So it gives me information about onset strength, and it also gives me information tempo value of this particular audio. So this tempo value is one of the threshold in acoustics. Based on that, you can decide that which samples to keep and which samples to discard. So this is very important filter that gives you this information. Based on this, we decide that, let's say if I have captured data set of, let's say 5,000 audios, I can decide that, okay, only 2,000 are capable to train the model and remaining I have to discard. That is extremely important process. So same thing I've done here, right? Applying different filters. So basically this is how we try to convert audio into grayscale, and then we try to understand it. Now, how I capture data. So I use acoustic sensors to capture this kind of audios. So even you can use a smartphone, it has microphone sensor inside. So you can capture those MP3 files or WAV files using that also. Then simply I store that on cloud. And then basically what I want to do, I already explained that I want to process these audios finally to classify them and correlate them with activities such as water tap leakage, shower leakage, flush water leakage, door opening, closing, cupboard noise, etc. Just like I explained that how we can correlate these ignorant noises with this. That was the idea. So I designed my own customized framework. So my idea was, it's a new area I'm exploring. So I can use a particular algorithm which I designed into multiple applications. So this is one application, but the same algorithm is applicable into 100 different applications. So again, physically it talks about the capturing data, and then I stored that on cloud. So this part is part of fog computing and storing on cloud. And then I design LSTM CNN based customized model. I train that model to classify this into the activities which I'm talking about. Before that, I had to do those things just like you're saying. So this is spectral representation, spectrogram representation of tap water, flush water, freeze, opening, closing, and chair movement. Likewise, I've considered actually 22 different activities in this particular case. And if you want to read in very detail, then there is a research paper available. I'll show you that a little later, right? So this is polygram information I got, extracted features, tempogram, just like I explained you. I got this information from this. And then always audio comes with noise. So I had to remove noise from here. So what I did actually, I use algorithm called LBP to actually remove noise. So convert this acoustics into texture-based noise robust images. So I can show you. So I use this particular algorithm for this data, right? So all these are the spectrogram images of 22 different activities I told you. And then this is converted into more texture form, as you can see, where I've removed noise. So what will happen is, if you give this sample along with noise, accuracy will be lesser. But if I consider this as input, then my accuracy will be higher. That's why I applied this particular algorithm. Just like you can see here, and yeah, right. So this is some mathematics behind how that LBP algorithm works. So basically we have applied two-level texture conversion here. Initially was audio. Audio we have converted into spectrogram, and spectrogram we have converted into texture form, something like this, right? And then I designed my own algorithm. So basically, what was the idea? That in which area this activity is happening. So tap water leakage is happening in a washroom. So I place one microphone sensor there. The remaining activity is happening in my bedroom. Then I place some sensors there. And likewise, in my house, I place the sensors at different places to create this customized data set. And based on that, using LSTM CNN based model, I classified this activity with respect to location in terms of tap water leakage, flush water leakage, etc. Right. So this was the LSTM CNN based model which I designed, and the overall training and testing accuracy I got. So I had less samples actually. So I actually considered augmentation here. Augmentation means you try to use the same samples to create more sample size, because working with deep learning, you need a large data set, right? So I use augmentation. So I got accuracy with augmentation, without augmentation accordingly. So almost close to 77% without augmentation accuracy I got, and close to 90% with augmentation I got with this. And then I did some comparison of samples without removing noise and with noise, what kind of results it's giving me for more experiments. And then, just like I told you that you need to work with multiple machine learning and deep learning. Likewise, I work with some machine learning and deep learning, and using LSTM CNN based model, I got a better outcome. Right, and then this was a confusion matrix I got for my work. I can show you a brief demonstration of this. Now, before I worked on this particular data set, what was happening was not a single data set was available for these events. And that was my interest, that why actually I worked on this particular work. So if you just search ambient acoustic framework, yeah, my research paper is available here. Right, whatever experiment I did, actually I published here. It's a good journal, Advanced Engineering Informatics. When you try to apply different advanced engineering, right, something like acoustics or multi-model kind of things, and you try to solve a particular problem, then this journal actually publishes work. It's a good journal, close to 10 impact factor it has, and you can publish your work in this journal. It's a good journal where they consider this kind of work, right? So whatever I did in detail is explained in this paper, right? So this was, and this is the model actually I designed to work with this. Right. So currently we have less time, so I'm not explaining everything in detail, but basically it's a CNN model, just like what we discussed. I designed customized model, right? And I train it, and then, as I told you, I consider augmentation. So with augmentation, without augmentation, I had to solve everything, and finally I got the required accuracy. Right. So that's how I designed this particular model. Now, same thing, as I told you, this can be applicable to multiple applications. So this is very interesting actually. So in 2019 itself, actually applied for Marie Curie Fellowship. It's a very well-known fellowship in Europe, right? So even though you're working in India, anyone all around the world can actually apply for this fellowship. So you can submit your research proposal. You can identify a mentor from foreign university, and you can together write a proposal. Only little bit challenging part is your proposal should get score above 95, right? To sponsor you to abroad countries, to particular research lab where you can carry out your research work. So I can briefly explain this particular project. It's very interesting one, and I'm still working this particular project currently. So similarly, just like I designed that framework, my idea was that as my research is healthcare actually, so how I can use all these things into healthcare, right? So this was the project actually I worked between 2022 to 24. Right? I got a grant close to 220,000 euro for this particular work. What was the idea? That currently a lot of cardiac related incidents are happening around us, right? So now everybody cannot afford ECG machine, because the ECG machine costs you almost 10 lakhs. Right, so you need to go to hospital to get diagnosed yourself, right, to know your own heart conditions. And that was the reason actually I was interested in this particular project. So my idea was that we should be able to design a proactive design at home, so that we know our normal and abnormal heartbeats in advance, so that at least even though we are not medical experts, but at least the system can tell us that there's something wrong with our heartbeat functioning or something, so that we should get meet cardiologist and get the diagnosis done. And that is where AI can really play a role here. Just like one of the sir was asking me question that AI is vague or it can really solve a problem. So this is an example where this kind of algorithms can really give you some information. I'll show you the demonstration also of this particular work. This is very competitive fellowship as well. Those who are interested, even I advertise every year. Those who are interested can apply. Now what happens is your proposal go to 3 different countries. So let's say 2 countries in Europe and 1 in UK, and your aggregate score should be 95 out of 100. So it's very competitive, and anyone from all around the world can apply. So people from Cambridge University, MIT, everywhere can apply to Europe, and it's for 30 countries of Europe. Likewise, there is such fellowship in Australia called Commonwealth. There is a fellowship called Einstein. That is in US. There is Fulbright fellowship in US. There's Banting fellowship in Canada. All these are well-known fellowships. And this fellowship can actually, for example, once you become Marie Curie fellow, you can write this forever. So it's a good tag. I'm sure everyone knows Madame Curie was doing a lot of research with Einstein, and they actually worked in physics in different way. So on that name, this fellowship actually has been designed, and it's very precious one, and you can actually try. It's a good bridge. You can try your postdoc using such fellowships. And if I have spare time at the end, then I'll try to explain you this fellowship, give you some more information on that. But I just gave you some briefings on that in case we have less time at the end, right? So this was about the project. So idea was that I wanted to process someone who has no cardiac issue, right? So whose heartbeats are normal, and someone who has some issue. And by applying acoustics, I wanted to extract information and then again train the model and carry out predictive analysis that who should actually get the diagnosis done at the end. Having said this, in this area, a lot of problems are there. So people actually just think that cardiac arrest and heart attack is same. It's not same actually. Cardiac arrest is different. Heart failure is different. Cardiac arrhythmia is different. Cardiac arrest is different, right? So actually, that's why I told you that I had to take some training from AIMS doctors to understand a little bit more in this area. Because I was interested to do something in this area, right? So in this particular project, I actually used benchmark dataset called PhysioNet, as well as created a customized dataset again using digital stethoscope. I captured some heart sounds of different individuals who are suffering from cardiac and not suffering from that. And likewise, I carried out some experiments. So that was the entire thing about the project. So again, I used the same acoustic arrangement to capture the sound. Only thing is I've used digital stethoscope to capture the sound instead of just microphone sensors. Then the similar algorithm I applied, even though I use different filters here, because as I told you, every problem has a different filters because you want to extract different kind of information. So in this particular case, what I had to do was, because what happens in heartbeat is it's called lub-dub, and there is specific sequence, and that sequence we need to study to identify that it's a normal heartbeat or abnormal. So I actually detected audio initially, right? Then I normalized those sound because capture audios were of different length. So I had to normalize it. Then I downsampled them into 3 seconds because that lub-dub sound, that variations that you can see on ECG, right? That I had to downsample into small chunks of 3 seconds, and then apply some filters to extract more information. And then I give it as input to my LSTM CNN based algorithm to classify them into normal and abnormal heartbeats. Right. So this is example of spectrogram. Already you know that it's a grayscale image of audio. And then these are some more filters. So I've applied chroma filters here. So you can see. So one example I can show you here. As you can see here, this particular example, if you see when I process normal heartbeat, you can see all these squares. These squares are actually in audio language called pitch resolution. These are music libraries, right? So when I process normal individual, you can see all the squares are very visible. But when I try to process audio, heart sound of abnormal individual, you can see it's very zigzag. So from this, I can easily get the information that there is something wrong here. And when I apply some more filters, I keep on getting more information on this. And based on that, I can train the model. And at the end, AI can really help cardiologists in diagnosis this kind of patients, because sometimes you do not have even enough time to reach to hospital, and we hear a lot of incidents around us, but there is no resolution right now available. right? So still technology is not reached that wisdom level we are talking about, where we can actually solve very complex problems. Just like sir was talking about space, likewise, many areas are there, a lot of different problems are there, right? Then same LBP algorithm I applied to convert to remove noise, to convert this sample spectrograms into texture forms, right? And in this case, every problem is different. So in this case, I had to apply downsampling. So I had to divide this into small chunks of 3 seconds to understand those variations, right? So and then I try to divide abnormal heartbeats into more forms. So these are some medical terms: murmur, extrasystole, artifact, miscellaneous. So these are the ones that are abnormal heartbeats. These are different types of abnormal, and normal means no issues that individual has. And then these subtypes can be further classified and correlated with the diseases I'm talking about, cardiac arrhythmia, and there are multiple things are there, right? So that's why I applied in this particular problem this, and this was my cardiac assistive framework that I tried to design and apply LSTM CNN-based framework to classify this into normal and abnormal heartbeats, and abnormal further into murmur, extrasystole, artifacts, and other miscellaneous ones. That's how this algorithm was designed. And in this one also, with augmentation, I got close to 90% accuracy. Without augmentation, the accuracy was a bit lesser. But still, it was a good experiment I carried out during my postdoc project, and these are some of the ROC, AUC results and some of the comparison of different algorithms that I try to carry out. Right, so there was some existing work, but I try to just increase the accuracy as well as my approach is a little bit different than others, and that's how I try to excel this particular problem. Right, so now, sir, I'm almost done. I just need to explain some of the ongoing projects, and then we can take the questions. So, right. So currently, I'm working with one of the Sweden university, where we are trying to design a conductive shock. So some of you might be knowing already about the dementia and Parkinson's, right? So in case of Parkinson, what happens is a person's particular body part is freezed for certain moment, and then it becomes normal. So basically, using vibration, we can capture that particular part, right? So we want to design a conductive shock which can detect gate phase detection. It's a very important thing as part of that, and this can finally find the possibility of Parkinson's among elderly individuals, right? So this was one project I was working with, and this is another project. Actually, we are working with Philips, where this is a thermal camera. So the camera we use actually cannot be used with babies, right? So if you want to capture emotion of babies, you need to have thermal camera, which is a little bit expensive. It's almost 4 lakh INR. If I talk about INR, it will cost you that much, right? But this can actually, while baby is sleeping, this can capture, because you know that sleep has 4 different stages. And one of the project actually with some research, foreign researchers from US, actually we are working on this, where we try to detect emotions of infants of 0 to 6 months babies on that. So there's some things, and yes, this is one of the project actually I was talking about. So this tunnel I designed, I installed at Symbiosis Pune actually, but now they are not using it, but it was installed and it was used by the staff. And later I try to take it forward. So just like sir talk about reinforcement learning, this was the health kiosk actually I tried to design, where I wanted to use AI controllers in real time to solve this particular issue of, so on this particular screen, you can see your body temperature live, and those who are not wearing face mask, using YOLO, we want to detect people without face mask and create a report and give it to security so that everyone will follow those rules during COVID. Right, so that was the idea, and some more information of the research paper is written in the published research article. And those who are interested to take maybe in healthcare informatics, then these are some of the research areas where you can take your research forward in postdocs, PhDs, even as a faculty. So translational research, already I discussed that when you merge 2 different areas into one, just like I'm working with the acoustics, images, text together in multimodal way, it's translational research. Now, in UK, we started talking about this, but maybe India, not we are talking this. Artificial superintelligence is the next technology where a lot of problems related to nutrition, fatigue, body, and etc. can be solved. Then there is brain. So mental health is another issue where brain computer interface can be integrated with health informatics. So I'm doing some research on that right now. Some projects are going on, One of the Marie Curie even a candidate had applied with me, submitted a proposal on this particular area with me, the fellowship I was discussing. So this particular area we are working with, and then in future cancer. So we hear a lot about cervical, mouth cancer, and bone cancer. It's still an open issues, and in this area, people can actually carry the research forward. So thank you everyone for patiently listening and bearing with me. I'm happy to answer any questions if anybody has, and thank you so much for your time. So, Chogle sir, I'm done. And if hello, Chogle sir, you can hear me?
Yes, sir. Yes, sir. Please.
Yes, sir. Sir, I'm almost done. If any questions audience have, and then we can start with our formalities that you were talking about. And
so there are certain questions.
Sure, sir.
First question is from Deepali madam. Which tool is used to check audio accuracy?
Okay, so there is one way is SNR. If you know, ma'am, signal to noise ratio. Right, so SNR techniques can be applied actually to identify the signal to noise ratio. So SNR 0 dB, 3 dB, 5 dB, different variations you can apply to do that. Because basically audio can be measured based on noise, attenuation, etc. So once you remove that, based on that, whatever experiment I did, based on that, you can actually detect that. So SNR is one way, can be used for this. But then every problem is different. So when I talk about digital stethoscope, your techniques will change, things will change. So every problem is different, but SNR is one common theory can be applied here.
Sir, recently in newspapers, there was a news that in China that a certain operation on a patient was conducted from 400 kilometers away. So the doctor was sitting somewhere 400 kilometers apart and the patient was in the OT. So they have conducted through AI. So how is this is done? What are the technologies which are involved in doing such type of operations or say conducting remote operations?
So those are basically you need here those kind of things where the 3D graphics and those kind of tools are available. So because it's more like remote patient monitoring. So when we talk about this, I forgot the name of the technology. When we integrate those things with this kind of technologies, it's not my area, but hologram we call it, or I forgot the name. So those things are actually being used. So more I can say more like 3D graphics based designs are actually applicable here. Basically, what you want to see is it's also a sensor, nothing but, and you just want to see while doing medical imaging or those things you want to see in real, right? So when the doctor is sitting remotely, basically what you want to detect is what is there inside the body, different parts you want to diagnose, you want to detect those those tumors if it is available, and based on that you want to carry out the detection. So that is the way it can be done. Even though my research areas are very much stick to acoustic health, so I'm more focused on that, and I'm working with preventive healthcare more in that sense. So I've not tried those technologies actually in my experimentations. I have a little bit information, but so we have in our university we have those 3D kind of computers available, where you can see the body parts in 3D and different things, and it's adopted by health. So we have a separate health science institute where some researchers might be doing something like that.
Thank you, sir. Thank you.
Sure, sir. But I have this much information, not much.
Oh, no, thank you, sir. Thank you. It's enough.
Sure.
Any other question from participants? Because soon we will be going for our feedbacks and assessment at 6:30. So before that, any questions are there, we can address, sir can address. Sir, there is a question. how to
Sure.
calculate signal to noise ratio formula, and how to measure values practically.
So this will come back to actually the sample size you selected, hertz, etc. So there are techniques available, and there are hardwares available which can do that for you. So once you give your input as audio to that hardware, it will give you signal to noise ratio. But only issue is every audio will have different kind of noise, right? So every audio will not have same amount of noise, right? So that variation. So for that you need to do, let's say, a simple audio. If you take, you need to apply SNR 0 dB, 3 dB, 6 dB, 15 dB, 12 dB, etc. to try those variations to see that what kind of outcomes you are getting. So it's more kind of experimental thing, but there are tools available for this. So using that, you can do that. Or otherwise, digital signal processing you can apply here to calculate the same thing. So something like MATLAB can be used here to calculate the same thing. There are mathematical functions available which can give you this SNR ratio information. But it should be able to take audio as an input. So basically, wavelet form as an input you should be able to give in the system. Then only this will work. So another example I can talk about is Whisper here. Recently introduced library is there. So if you tried, this is introduced by OpenAI, text to speech and those kind of issues. So here all those examples are given where how we can process audios and how we can work with that, how we can encode, decode, etc. is given. So you can see here spectrogram example is there, and they've given some architectures. So you can explore some more on this, and because digital signal processing was very complex, now it's very easy to work with this. Even a lot of research is carried out at Google Brain team as well. So if you are aware, let's say if you want to carry out your postdoc at Google, so they have every year there is one thing going on, and you can join this particular team. Again, it depends on the proposal you have and what kind of background you have built in that particular area, and you can actually join this team as well. Where a lot of research is happening on this kind of things. So I hope I answered your question.
Yes, sir. There is.
Sure.
We are taking the last question from
Sure.
Deepali, madam. Can you list some name of tools she hasn't mentioned, but I think it is related to the acoustics or
So,
say AI tools, maybe.
Basically, what I've done is AI, right? So basically, previously what we used to do was we used to apply digital signal processing techniques like STFT, different Fourier transform techniques and short-term Fourier transform and all those things. The same thing is now is converted into machine learning libraries. So all those things are just available in terms of functions, which I have applied. But one thing I can talk about recently, I'm working with mental health, where I have to actually use different kind of headsets to capture the data. So BCI headsets are something is as a tool I'm using right now. So Emotive is one of the famous hardware where I'm trying to combine acoustics and mental health neural oscillation data together, because again it's a signal and actually applied to. So if I show you those things, so Emotive Pro is actually the hardware. It's already available, which can help you with this kind of mental health data. But with audio, simple digital signal processing is more than enough. Only thing is just SNR and just like you talk about. So there are some tools available, but again, those things are just basic that you can do it using mathematics also. So no tools are required to work with acoustics actually. But this particular headset I bought recently to capture neural oscillations. Right, so because I wanted to combine mental health, neural oscillations with heart sound to decide that when cardiac arrest happens, right, what is the mental health condition of that particular person. So that is something in that area I'm working on. So this is where you need, because you need some kind of interface to capture data. But in case of acoustics, maybe digital stethoscope in case of, let's say, cardiac arrest. But I don't think so that you need any specific tools for that. And if it is available in the market, I'm not much aware of it, because this is how I've carried out my experiments, and these are the things I've used actually.
Okay, thank you, sir.
Sure.
We will move forward after this interactive session.
Sure, sir.
So good evening, everyone. On behalf of Sadhu Vaswani Institute of Management Studies for Girls, Pune, and the organizing team of the Faculty Development Program on Next Generation Technologies in Action, Generative Artificial Intelligence and Quantum Computing, it is truly my honor to express our deepest gratitude to Dr. Sharnil Pandya. Sir, your two sessions today were more than just talks. They were profound explorations into the future. By intertwining research with real-world applications and thoughtful insights, you have illuminated how artificial intelligence can transform healthcare and enhance human well-being, as well as how it can push the boundaries of sound and intelligent systems. Your genuine passion for interdisciplinary research and your willingness to share valuable opportunities for postdoctoral studies and research funding abroad have genuinely inspired us. As we wrap up today's enriching sessions, I hope we all carry the motivation, knowledge, and possibilities offered by Dr. Sharnil Pandya into our classrooms, our research, and for future. Thank you, sir, once again for your invaluable time, wisdom, and for being here with us today. As we conclude today's session and prepare to enter the final phase of our faculty development program, we have scheduled the valedictory function at 7:30 p.m. It would be our honor and privilege to have you, sir, Dr. Sharnil Pandya, sir, grace the valedictory ceremony with your presence. We request you for your presence. Your guidance throughout the day has been invaluable, and we would be most appreciative if you could join us once again to formally conclude this program. As we draw these inspiring sessions to a close, let us channel our learning and enthusiasm into the final online assessment, a step that reinforces and celebrates our growth. Thank you, sir. Thank you so much.
Thank you so much for coordinating everything. I also want to thank Dr. Nanwani ma'am, Chogle sir, and the entire team, everyone who has helped me throughout this. Thank you.
Thank you, sir. So there are some instructions for participants regarding the assessment. Dear participants, we have now arrived at the final concluding stage of our faculty development program. The final test is scheduled from 6:30 p.m. to 7:30 p.m. through the ATAL login, and it begins right now from 6:30. So please remember that the qualifying criteria is minimum of 70%, with all participants to be present online for the valedictory ceremony. Immediately after completing the test, kindly log into your ATAL account and submit the final feedback form also through your ATAL login. After the test, we will proceed with the valedictory ceremony from 7:30 to 8 p.m. All participants are cordially invited to attend. Kindly do not leave the meeting. This is very important. In case you get disconnected, please rejoin so that you can be part of the valedictory ceremony. Regarding certification, the AICTE e-certificate will be made available for download once your test score and attendance is uploaded by the coordinator and the feedback process is complete. The organizing team will inform you directly on WhatsApp group as soon as the certificates are live, and be there for a valedictory session. Thank you once again for your active participation and wish you all the best for online test. Thank you so much. Please do not leave the meeting. There are some instructions which will be displayed on the screen for you, that will help you to for the assessment and submit the final feedback through your ATAL login. Thank you so much. Dear participants, I am repeating some important instructions. The final test is scheduled from 6:30 p.m. It will be start at 6:30 p.m. in your ATAL login. Please remember that the qualifying criteria is a minimum 70%. You need to secure at least 70% for your eligibility of certificate. And we have valedictory session from 7:30. Please be there. Do not leave meeting. If any participants wants to share their feedback, they can raise their hand. We will allow to share your valuable feedback. Thank you. Yes, Mandar sir, I have allowed your mic. You can speak now. Hello. Hello. Mandar sir, your mic is allowed. You can speak now. You can share your valuable feedback.
Yes, good evening, participants. Uh, Good evening, everyone. Uh, as we are moving ahead, I will share some important guidelines, AICTE guidelines that ensure the smooth conduct of this assessment and feedback. Very first, in line with the AICTE norms, attendance will be mapped through the feedback system during each session as well as the Teams login and logout logs. We kindly request your all that if it is 80% participation was there, that way your attendance will be marked over there. Regarding final assessment, the concluding test is scheduled today from 6:30 p.m. It will start from 6:30 p.m. Here you can notice on the screen that after login to your ATAL portal, you can move to the test, and the test right now also, if you will notice, that it will show you the test will start from 6:30 sharp. Now a minimum of 70% in the qualifying is the qualifying criteria, and we are confident that your engagement throughout will make this meaningful experience rather than a formality. So all the best to participant for the final test. Parallelly, feedback immediately after the test, participants are requested to log in to the same ATAL account, and you can complete your final feedback process within the same time frame. You are having the time frame that is between 6:30 to 7:30. During this time period, you are supposed to mark your you are supposed to appear for the online test, and please give your feedback on the ATAL portal only. The regarding certificate, the AICTE e-certificate will become available to download once the test scores are uploaded and the feedback loop is complete, and the attendance of yours will be submitted on the portal. So accordingly, we will communicate the availability on the group also. So participant, we deeply appreciate your cooperation in aligning with these norms. These steps are not mere formality, but essential for upholding the standards that make FDPs like this truly impactful. And once again, I request you all to be over here on this same meeting, or you join it at 7:25. We will be having valedictory from 7:30 to 8 sharp. I request the participant, if you want to share your feedback with us, so please raise your hand. We can unmute you and please share your feedback with us. Participant, if you can raise your hand, we can unmute you. Please share your feedback over here. Even you can share your feedback on chat also. Rapti madam, the attendance will be uploaded on the portal only. You can check it from there. Yes, sir. Saket, sir, on ATAL portal, you have to log in with your credentials. Using that, you have applied for the FDP. Next, you can see on the screen also, like there, as you log in, left-hand side panel, you are supposed to select the test. And as you click on the test, one screen will be there, and there you have to mark, just mark the tick, and you can start the online test from that. You can see over here on the screen, it is shown over here. You can leave the meeting, but please be available at 7:30 for the valedictory function. Yes, Hemant sir, it will not be able to open right now. It will start from 6:30. We will check once. 1 second.
Admin.
Participants who are asking for where do we have to go, you can just notice the screen is going on. you can click on left hand side, you can click on the assessment, and there you will see a quiz link. You can click on that. You just select over that over there a tick mark over there, and start your quiz.
Uh, Ashish sir, you can unmute yourself, sir.
Yes, yes, yes. Am I audible, Shweti ma'am?
Yes, sir. Yes, sir.
Dear participants, can I have your attention please for a minute? Dear participants, there is a problem with online tests on ATAL portal as well as feedback. Both online tests and feedback are beyond the control of the college and is in AICTE domain. So we have made an alternative arrangement. We have created a Google form for the test. Participants are requested to attend the test on the Google form. In a short while, we will also have a feedback form uploaded on the WhatsApp group so that you can fill the feedback form also. I repeat, the problem is with all the participants, very few participants were able to go through the test as well as the feedback form. There is a problem with the portal as of now, which cannot be corrected today being Saturday. So we will find out a solution with talking to the authorities with AICTE ATAL on Monday and will provide a solution to it. Till then, all the participants are requested to please appear for the test on the Google form as well as a feedback form which would be shared shortly. We sincerely apologize for the things that had happened which were beyond our control. Everything was uploaded from our end well before the time. So kindly bear this problem, which is a technical glitch on the portal itself. Without any delay, I request participants to please attend the valedictory program, which would be scheduled to start at 7:30. And we are, I suppose, already on time to start with the valedictory program.
Good evening, everyone. Honorable Parag Karkar sir, we welcome you. We will start just within a minute.
Okay, thank you. I'm there. Don't worry.
Thank you, sir. Director Madam, shall we start?
Yes, please. Please
Yes, ma'am.
start. Yes.
Yes, ma'am. It is my privilege to welcome you all to the valedictory session of ATAL-sponsored 6-day online faculty development program titled Next Gen Technologies in Action, Generative AI and Quantum Computing, organized by Sadhu Vaswani Institute of Management Studies for Girls, Pune. Honorable Pro Vice Chancellor Savitribai Phule, Pune University, Dr. Parag Kalkar, sir, you will be happy to know that during the past 6 days, we have covered significant ground. May I run through the FDP summary processing? Sir, with over 450 applicants, this FDP has over the past 6 days brought together a dynamic and diverse group of more than 395 participants from across India, including teaching faculty, industry professionals, and research scholars. This vibrant community of learners has greatly enriched our discussions and overall learning experience. Throughout the FDP, we had a privilege of welcoming several distinguished speakers from academia and industry who shared their expertise on wide range of cutting-edge technologies. So, Mr. Shivi Gupta introduced us to agentic AI, its ethical and moral responsibilities, and mastering prompt engineering using GitHub Copilot. Dr. Preeti Bhule guided us through generative AI tools and hands-on practices for automating data analysis. Dr. Suresh showcased how generative AI enhances creativity and supports research through design thinking. Dr. Catherine Kane and Professor Dr. Aswani Kumar Cherukuri bridged the gap between generative AI and quantum computing, discussing research trends, ethical considerations, and the future of quantum technologies. Mr. Rajesh Korde emphasized the integration of cybersecurity with quantum AI. And finally, today, Dr. Anindita Banerjee and Dr. Sharnil Pandya explored quantum security and the applications of AI in wellness and acoustics. So each session offered valuable insights into the field of AI and quantum computing, highlighting not only the technical advancement but also the societal and ethical responsibility we must uphold. Among the many participants, some participants desired to speak about their learning and experiences gained through this FDP, and hence we invite for very briefly expressing their thoughts. I request technical team to unmute Dr. Dipali Borse from MIT VPU Pune.
Rights given. Deepali madam, you can unmute and please express the feedback.
Yes, sir. Am I audible?
Yes, ma'am. Yes, ma'am. Perfectly.
Good evening, all. I am Dr. Dipali Borse. This 6 days FTP on generative AI and quantum computing in action organized by SVMIS was enriching and well structured. Each session was thoughtfully designed, balancing the theory with interactive and hands-on learning. The speakers like Mr. Shivi Gupta and Dr. Preeti Moen has delivered insightful sessions on ethics, prompt engineering, and practical tools. Dr. Sharnil Pandya's session on today on his research in AI for wellness and acoustic was very insightful and opened new dimensions of the application. So overall, it's an excellent initiative by SPMIS that successfully blended knowledge, practice, and futuristic insights. Thank you.
Thank you, ma'am. Next, I request technical team to unmute Dr. Mittal. Dr. Mittal Bhayani, she is Associate Professor at MIT's Institute of Management, Bhujbal, Knowledge City, Nasik. Mittal, ma'am.
Mittal madam, you are unmuted. You can please express your feedback.
Yes, am I audible there?
Yes, ma'am, perfectly.
Yes, good evening to one and all. Thank you so much for giving me the opportunity here. The last entire 1 week was excellent, sir. I would especially mention a very big thank you to Sadhu Vaswani, entire team, and Atal FDP for making us enriched with so much of knowledge. Being from a non-technical background, like we are not from engineering background or don't have, and not from that domain. So when we first read the title, it was like may not be it is for us or should we attend or not. That was the question in our mind. But still, if we attended since it was for management also, and then we realized that interdisciplinary approaches so much of importance, and we would have missed so much of the content which is making us relevant in the market, at least at the academic field as of now. So right from day one till today, each and every session gave us so much of inputs using generative AIs, enriching academics, enriching teaching, and so on. So I personally feel that it has added lot of value to me. I'll definitely ensure that I leverage everything that I've learned in this FTP and contribute to academics in the management. So thank you so much to everyone over there.
Thank you, ma'am. So now it's my pleasure to introduce our chief guest for this valedictory session, Honorable Pro Vice Chancellor Savitribai Phule, Pune University, Dr. Parag Kalkar sir, whose esteemed presence honors us today. Honorable Dr. Kalkar sir's academic journey is a blend of deep scholarship and visionary leadership. Sir holds an MCom, MMS in Finance and PhD, along with completing the prestigious Faculty Development Program at IIM Ahmedabad. With over 2.5 decades of teaching and administrative experience, Sir has played a pivotal role in shaping higher education in Maharashtra. Before resuming the office of Pro Vice Chancellor, Sir served as the Dean of Faculty of Commerce and Management at SPPU. His leadership journey also includes prominent roles such as Director of Sigad Institute of Management, Campus Director and CEO of Sigad Lonavala, and key positions like Deputy Registrar Academic and Deputy Registrar Admissions. He has also been an active member of the Senate and Academic Council of the university, contributing extensively to the academic reforms and governance. Sir's scholarly contributions are completed by his vision for sustainable development and entrepreneurial innovation. Sir has been a strong advocate for green initiative, waste management solution, and sustainable entrepreneurship models, area that are critical for the future of our cities and our economy. Sir's dedication and excellence have been recognized through several prestigious awards, including the Best Teacher Award by the Government of Maharashtra, the Best Director Award by the Pune Management Association, and accolades for his contribution to research, management education, and academic administration. These honors reflect not only his professional achievements but also his commitment to nurturing the future leaders. As the Pro Vice Chancellor of SPPU, Honorable Dr. Kalkar sir continues to guide the university towards academic excellence, effective implementation of National Education Policy NEP 2020, strengthening the industry academic linkages, and fostering innovation across disciplines. So, ladies and gentlemen, please join me in welcoming a leader who embodies knowledge, vision, and dedication, Honorable Dr. Parag Kalkar sir. I kindly request Honorable Dr. Parag Kalkar sir to address the gathering. Team, please unmute, sir.
Yeah, I hope I'm audible.
Yes, sir.
Very
Yes, sir,
good
yes.
evening. Thank you and good evening to everyone. The Director of SVIMS, Dr. Nanwani Madam. It's an honor to share my thoughts before you today at the valedictory session for the Generation Next technology, generative AI, and quantum computing, a faculty development program. I think the 6 days faculty development program is getting close today. And these are exploring the two most transformating field in modern technology. The power of next generation teacher. This program is not just about learning new tools. It was about preparing for the future of education. As a teacher, you are the architect of next generation. You are not just imparting knowledge, you are speaking curiously and equipping the student with a critical thinking skill they will have needed to navigate a world increasingly shaped by the technology. You are delved into the intricacies of generative AI, understanding how models like ChatGPT and Dell-E create new content. And more importantly, those tools can be harnessed to personalize learning, automate administrative tasks, foster creativity in the classroom. You are also grappling with the mind-bending principles of quantum computing, moving beyond these bits and bytes of traditional computers to a world of qubits, superposition, and entanglement. It isn't just a theory, it's a glimpse into the future where we can solve complex problems once considered impossible, from the drug discovery to climate modeling. Over the past 6 days in this ATAL sponsor faculty development program, I think you all have been fortunate to learn from diverse group of experts. The first day, Mr. Shiva Gupta from Cognizant guided you through the ethics and moral responsibility of agentic AI and taught you the master prompt engineering from GitHub Calipot. You have this Preeti Mule who provided the hands-on experience with cutting-edge AI tools and taught you the automate data analysis. Suresh Nambudri showed you how generative AI can be used for interdisciplinary research and enhance the creativity within design thinking. We have tried to bridge the gap between two revolutionary fields, the Catherine kind who explore the synergies of future prospect of generative AI and quantum computing. Professor Dr. Ashwini Kumar has given us a comprehensive introduction to quantum computing, where Rajesh Korde spoke on the critical topic of cybersecurity and quantum AI integration. Finally, today, I think the session is concluded from Dr. Anandita Banerjee and Dr. Sharil Pandya, who shared the insight of quantum security, AI for wellness, and AI for acoustics. The knowledge what you have gained in this 6 days FDP is a powerful asset. So I encourage you to innovate in your own classroom. Don't be afraid of experimentation, because NEP 2020 is only experimentation. Try to integrate those technology into your teaching methodologies to create dynamics and engaging learning environment. Show your student that technology isn't a replacement of human intellect, but a powerful extension of it. The key to it is to teach them not just what to think, but how to think alongside these incredible tools. We are not going to make artificially intelligent students. We want to make them real intelligent. So artificial intelligence and real human intelligence should work together hand in hand. This program will not end, but it's a beginning. The field of generative AI and quantum computing are evolving at a breathtaking pace. And your commitment to lifelong learning will be your greatest tool. The future of education is in your hand. The future of generation is in your hand. And I have no doubt that you will lead with the vision and passion that has been so evident throughout this program. So I congratulate you for successfully completing this program. I congratulate the institute, the director, the coordinator of this program for the patient handling of this program, ATAL FDP, including the evaluation. Thank you. Thank you very much.
Thank you, sir. Thank you for your inspirational address. Your words have truly motivated us to move forward and organize many more such impactful events in the future, sir. Now, I invite our esteemed director, Dr. B.H. Nanwani, to share the concluding remark.
Good evening, Honorable Pro Vice Chancellor, SPPU, Dr. Parag Kalkar, staff of SVIMS, and all the dear participants who have hailed from different parts of Maharashtra, as also outside Maharashtra. Today is the time when we must draw curtains on this program, as any other program and event is always destined to have. It's only for a particular time that we meet, that we embark on these journeys of learning. And as I said, the time comes for drawing the curtain. But this is not going to be a full stop. I'm very sure that the FDP has ignited new areas of learning, and you are raring to go. As Sir said, this is the starting point for us to explore how we can use generative AI and quantum computing even in our day-to-day teaching, in our research activities, and so on. Sir also spoke about human intelligence, and Sir, you will agree with me that SVIMS is raring to go not just in creating artificial intelligence, but we build on building human intelligence. We've always focused on ethics. We've always focused on morals and ethics in our students through special classes that are called the Sanctuary. You're very well aware about it. So we are happy that you spoke about it, and I take leverage out of this. I must say from our lens that, of course, the feedback will tell its own story. But from our lens, we feel that we have been successful in achieving the outcomes that we had outlined. We had in our minds that we would impart foundational knowledge and concepts in AI, quantum computing, concepts like zero-day threat prediction and so on. As one of the participants said, we did not expect that we would have such a diverse crowd, and it was our duty to help them dive deep into these concepts so that they can be using it for their pedagogy. So we have been able to impart this foundational knowledge. We've also been able to give hands-on training, much as it is difficult in an online mode with so many participants on board, but we have been very successful in having applications demonstrated and scholars actually using these applications like GitHub Copilot, prompt engineering techniques. We've helped people to use prompt engineering techniques to get better responses from large language models. We have been able to help all the participants to actually use AI platforms, both for pedagogy and research in cybersecurity, in acoustics, wellness, etc. Embedded in each session, sir, we tried our best to include, real-world applications, industry use cases, so that there was a better absorption of the knowledge. In that sense, we feel that we have been successful in achieving our outcomes. And of course, we did not leave aside the very important ethical issues that are looming large in the sphere of using AI, generative AI, quantum computing, and so on. Much as it is a very exciting field, we just cannot ignore that unless and until there is a sensitive human intervention, these machines can and may bring in our extinction. This may be a far-fetched fear, but nevertheless, it can be there, and we need to tread with caution. On that note, that we have been successful, I would like to now extend my thanks to various kinds of people. First and foremost, Dr. Shweti, I'm indeed very proud of you. As co-coordinator of this FDP, you have executed this entire program with elan, with excellence, and I really can't thank you enough. I also wish to thank the technical team we have a couple of people out there, Mr. Abhilash, who is the systems engineer, Rajesh Shelar, Dharmendra, Dr. Deepak, faculty member of MCA, each and every faculty member of MBA and MCA who really put their heart and soul into it, the librarian and so on. Without their help, of course, this FDP would not have materialized, and AICTE must be thanked because unless and until they do not sponsor these current topics, research in these emerging fields, not many would be enthused to really take up these programs. Dr. Kalkar, I see you like an indulgent parent. So just like a parent is always, motivating their family members, their friends, to move on in the journey of excellence, Dr. Kalkar, as Pro Vice Chancellor of the SPPU, indulges in institutions like ours. He's all the time enthusing various institutions to move on the journeys of excellence, and his presence, sir, your presence really means a lot. And we all are encouraged by the fact that we've got a dynamic person like you who is combining traditional wisdom and also is modern enough to accept the latest trends and encourage people to take up research and other endeavors in this field. Your presence means a lot, and I want you to know about this, sir. Each of the participants, thank you, sir, thank you. Each of the participants, my very big thank you. You have placed your trust in us to embark on this journey of learning, and I appeal to you that continue to keep this faith reposed in us. We will be holding many such programs, and we would like you to join in together with us. Thank you once again, each and everyone. Thank you.
Thank you. Thank you, madam. So, ma'am, can we conclude it now?
Yes. So with this, I'm sure Dr. Kalkar's permission is there to declare the program as closed. So please go ahead and do the honors.
Yeah, this program where I think learning has started. Madam has rightly told that SVIMS, they're doing something innovation. The AI on all these things, quantum computing is not going to replace, because AI cannot capture human emotions. Ethical practice is also more important. So it will support the technology, because personalized learning solution we have to create for the student of the future. So these all technology need to be embedded properly as per the choice of teachers. So you can do an experiment, share the best practice with us. Don't read that FDP is over when you get a certificate, tata, bye-bye. Share with other colleagues also who are present today. And I think that will clear learning for all of us also. The university will be also happy, and AICTE will be also happy if you create some of your own model, and then that model will be shared. That will be helpful for the nation. So thank you very much. And I declare that FDP is closed formally, but informally, all learning continues. Thank you very much.
Sure, sir. Sure. Thank you so much. With the leadership, such a good leadership we have with us, our director, madam, and surely we'll achieve this. Thank you, sir. Thank you, all the participants. We can end the meeting now.
Yes, Shweti. Yes, Dr. Shweti, you can, right?
Yes.
Just tell them about, once again.
Yes, ma'am.
Yeah. Dear participants, we would like to assure you that even if there have been technical glitches, not something to do with us, but with the ATAL portal, we assure you that full justice will be done to you. The Google Forms have been floated, and please do attempt your tests, and your records have already been there in context of attendance. So if you have fulfilled your norms, please please rest assured that you will get your certificates. And thank you once again for being patient. We understand that it's very difficult after a long day of work at the institute. You have still, managed to get onto this FDP, complete it. And we are really, really very grateful. Thank you for your patience, even with the technical glitches. And may the journey of learning continue.
Thank you. Thank you, participants.
Yes,
And
I don't know if the resource people are also available. I couldn't see them, but I would have loved if the resource people were there at the valedictory function. But we must extend our gratitude to each of the resource people who have made this journey of learning truly, truly meaningful.
Yes, ma'am. Sure. We'll convey
I don't
them.
know if they
Yeah.
are there. I can't see them.
No,
Okay.
ma'am. I think so. They have left.
Okay.
Yes,
okay.
ma'am. Yes. Participant, we request you all also to share your feedback on the WhatsApp group if you want. And we request if you can send a recording of your feedback to us. So we will be obliged. Thank you all. Thank you and happy learning. Yes, technical team, we can end the meeting.
Okay, ma'am.